Hello students, welcome to the chapter Flow of Control. This is the part 1 of this particular chapter and today we are going to discuss about Introduction to Statements and its flow. So let's discuss about the concept of statement. Now what do we mean by a statement? See, while writing a Python program, we write various statements, various programming lines of code. Each line of code in the Python programming language is known as a statement. For example, if I write x equals to 5, y equals to 3 and then print y, then x equals to 5, y equals to 3 and then print x, all these three are known as statements. So what are statements? These are the instructions which we give to the computer for performing some operation. So the instructions given to the computer to perform any kind of action are known as statements. Statements are basically divided into three types. One is the empty statement, second is the simple statements, and finally we have the compound statement. Let's begin with the concept of empty statement. Now what is an empty statement? A statement that does nothing is called as an empty statement. So a statement which does not do anything is called as an empty statement. Now you might wonder that if the statement does not do anything, then why is this statement required at all? This statement is required because sometimes the syntax of the Python programming language demands that some statement must be there, but the logic of the program does not want that any statement should be there. So in that case, we will be using an empty statement. The empty statement in Python, it is referred to as pass, P-A-S-S. So whenever you want to write an empty statement, you will just write the word P-A-S-S, which is pass. Now whenever pass is encountered in a program, the program does nothing and moves to the next statement. So whenever Python will see that pass is there in the program, then the program will not do anything and it will simply move on to the next statement. The pass statement is useful in cases where the syntax of the language requires the presence of a statement but the logic does not. So if in certain situations, as per the syntax, if a statement is required, but as per the logic of your program, no statement is required, then in order to bypass the error, what you can do, you can simply write the empty statement which is pass. Okay. So for example, let's say I am developing a software for an ATM machine. So for that, let's say there are three functions. One is let's say balance inquiry. Second is let's say deposit. And third function is let's say withdraw. Now for the time being, I don't have information as to how to go about balance inquiry and deposit function, but I know how to write the withdraw function. So for the deposit and balance inquiry function, we can just define the function and leave it blank. Now for leaving it blank, what we can do in these two cases, we can use the empty statement pass in this case. Now let's try to see how to do it. So regarding functions, you will get in class 12. But for the time being, I'll just explain it in brief. So a function begins with the keyword def. After def, we'll write the name of the functions. Let's say the name of the first function is balance inquiry. We don't have any information regarding this function. So in the next line, what we'll write, we'll just give the word pass. Next function is, let's say, withdraw. Okay. And let's say we have some information regarding the function withdraw. Let's say the balance at the beginning was, let's say 50,000, and out of that, let's say 500 has been taken out. And after that, let's say the current balance will be the total, the available balance currently minus the withdrawal. And let's say we'll just print it out, print current. This is how we can write a function. After that, let's say we'll write the third function, which is the deposit function, and let's say we don't have any idea as to how to proceed about this function at the moment. So what we can do, we can simply write pass in the next line. And now let's say we'll call the function withdraw and then simply run it. You will find that I'm getting the answer as 49,500. Now how it is running? So as Python encounters def, it will just simply skip to the next function, which is def withdraw. Then it will simply skip to the next function, which is line number 8, and then it will skip to the main program, which is line number 10. In line number 10, we have called the function. This is called known as function calling. Everything you will get in class 12. No need to worry about that. And as we call a function, the control will go over here and it will implement this logic. Now, if I do not give the pass here, then what is Python expecting? Python is expecting that I'll give the logic for balance inquiry function. So if I just run it, I'll get an error here. So in those cases, when you are not sure of the logic currently, you can just write pass, or if the syntax demands a statement but the logic of the program does not demand any statement, in those cases also what you can do, you can simply write the word pass. That's about the empty statement. Let's go to the next type of statement, which is the simple statement. What is a simple statement? A single statement in Python is called as a simple statement. If we have just one statement in Python, it is known as a simple statement. Now if I write print hello, this is called as a simple statement. If let's say we write 3 lines, x equals to 3, print hello, and y equals to 5, then we have how many simple statements? Then we have 3 simple statements. Each statement is known as a single simple statement. So what will be the output that we'll get? We'll get the output as hello here. Next type of statement is the compound statement. What is a compound statement? Now a compound statement means a group of statement which is written within a block. Now a group of statements in Python executed as a unit is called as a compound statement. A compound statement in Python, it has a header which ends in a colon and the body containing a sequence of statements at the same indentation level. So here in case of a compound statement, we'll have a header which is known as the compound statement header. Now within that header, whatever statements we'll be writing, all these statements as a combination, these are known as what? These are known as compound statement. For example, if I write if a greater than 5, and in the next lines if we write print high and print value of a is more than 5, high and value of a is more than 5, these two statements are known as compound statements. Why these are known as compound statements? Because these are a block of statements. How can we know that these are blocks of statements? Because after the statement heading, that is if a greater than 5, we are giving a colon over there. Okay, how if statement works, that we'll see in the next part. Now let's go to the statement flow control. Statement flow control means the manner in which the statements in Python are executed. It is known as statement flow control. So the manner in which statements in Python are executed is known as statement flow control. Now after which line, what will be the next line to run? And after that line, what will be the next following line to run? It is denoted by the statement flow control. There are basically 3 types of flow control in the Python programming language. The first type of flow control is the sequence flow control, which is followed by the selective flow control, and thirdly we have the iterative flow control. Let's begin with the sequence flow control. Now till now, whatever programs we wrote in class 11 in Python programming language, we did not skip any line in between. All the lines were executed line by line or one after another. Now if the program runs in that manner, one after another without skipping any line in between, it is known as sequence flow control. Now, so if the statements in Python are executed one after another, that is line by line, then the flow of statements is known as sequence flow control. In this type of flow control, all the lines are executed without skipping any line in between. So in case of sequence flow control, you will find that no line is skipped in between. All the lines are being executed. So Let's try to understand with the help of this diagram. Statement 1 will be executed, then statement 2, then statement 3, and then all the statements one after another. For example, here we have 3 lines. Hi, this is sequence flow control, and print the end. Here you can see that at first the first line will be executed, then the second line will be executed, and then the third line will be executed. So if we run this program, what we'll get? We'll get all the 3 lines in the output screen. So remember, in case of sequence flow control, all the lines are executed one after another. Let's try to give another example of sequence flow control. Let's say I'll just write a simple program to add 2 numbers. Let's give x equals to 5, y equals to 3. Let's write z equals to x plus y, and then print sum comma z. I'll just run this program and I find that the answer is sum 8. Now at first the first line has been executed, then the second, then the third, and then the fourth line. It is known as sequence flow control because the lines are executed one after another serially. Next, let us go to the next type of flow control, which is the selective flow control. Now in this case, a statement or a group of statement is executed based on a condition. Now this is such type of flow control mechanism where all the lines are not executed. Only certain specific lines are executed. So which lines will be executed? It will be dependent upon a particular condition. If the condition is fulfilled, a group of statements will be executed. If the condition is not fulfilled, a different group of statement may be executed, or that particular block may also be ignored. So if a condition evaluates to true, a course of action is followed, otherwise a different course of action is followed. For example, let's say we have a condition, the condition may be true. If the condition is true, a group of statements are executed, and if the condition is false, then what happens? A different group of statement is being executed. This is known as selective flow control. Here what will happen? All the lines of code will not be executed, only certain specific lines of code or line of code will be executed, and it will be dependent upon a condition. Okay, so for this, for understanding this, let us take a program, a simple program which checks whether a person is eligible to vote or not. So if I write x equals to 17, if x greater than equals to 18, what it will check? It will check whether the value at x, which is 17, greater than 18 or not. Is 17 greater than 18? Is 17 equals to 18? No, it is not. Therefore, whatever is written within that block, that is line number 3, will be ignored, and the control will go to the else part. Within else, what is there? Not eligible to vote. So what you will get in the output screen? In the output screen, you will get not eligible to vote. Now here you can see x greater than equals to 18. What is this called? This is known as the condition, and we'll get the output as not eligible to vote. Here you have seen that all the lines of the program are not executed, only certain selected parts are executed. Therefore, it is known as selective flow control. Let's try to quickly implement this particular program. So if I just write here x equals to 17, and if x greater than equals to 18, let's display a message like eligible to vote. We could have made it more user friendly, but now my intention is to just teach you selective flow control. So therefore I have just explained it in brief. Regarding the syntax of if and else, all this will be learning in the next part, in the next session. So here we'll be writing not eligible to vote. So now if I just run this program, we'll find that the answer is not eligible to vote. Why? Because this condition is not fulfilled. So we can see that all the lines are not executed, only certain specific parts are executed. Therefore, these type of statements are known as selective statements, and the flow control mechanism is known as selective flow control. Let's go to the last type of flow control mechanism, which is the iterative flow control. Now, what is the meaning of the word iteration? Iteration means repetition. So in Python programming language, sometimes some situation occurs where same type of things is repeated, should be repeated again and again. So if such type of situation occurs, then what we will do, we'll take the help of iterative flow control in order to minimize the task upon the programmer and also to minimize the lines of code from the Python code. So in this case, a statement or a group of statements are repeated depending upon a condition. So the statements are repeated until the condition evaluates to true. So till the condition will evaluate to true, the statement within a particular block are being repeated, and once the condition evaluates to false, then the statements within that particular iterative block will be ignored. So the statements under iterative flow, these are also known as what? These are also known as looping statement. So what will be there? There will be a condition. If the condition is true, a block of code or a group of statements will be executed, and after that particular group of statements execution is completed, then again the control will come back and check the condition again to see if the condition is true now also or what. If the true condition is true even now, then this block of statements, that is statement 1, statement 2, statement up to statement n, will get executed again and again. Generally, a time comes when the condition evaluates to false. Now, when the condition evaluates to false, then what happens? That loop is exited, and then once the loop is exited, that particular iteration or that particular flow control will not be executed. Okay, so let's try to understand it with the help of a code. Let's say you are asked to print your name 5 times. So ideally, by the concept, you know what you will do. You will just write print statement. How many times? You will write print statement 5 times. But is the program efficient? No, the program is not efficient because we are doing similar type of tasks again and again. So in those situations where you tend to do similar type of tasks again and again, so in those situations we'll use the concept of iteration. So yeah, this is from the concept we know till now. If someone asks you to print your name 5 times, you will do in this manner. If I just run it, you will see that I'm getting the name Alice how many times? 5 times, because I've given print statement of the same command 5 times. Now it can be done with the help of an iteration in just 2 lines. Let's see how it can be done. Now this is just a brief discussion on iterative flow control. Regarding the detailed discussion, I'll be discussing in this chapter only, but in the subsequent parts. So let's write a code for I in range 0, 5. I'll be explaining it to you properly in the next part, in the upcoming part. So here let's write Alice and let's run it. So you will find that just with 2 lines I am able to display the output. How many times? I am able to display the output 5 times. Now let's try to understand how this code executes briefly. So what was the code we wrote? We wrote for I in range 0, 5, and sorry, let me write 5 properly. Here I'll write print Alice. Now this range, the range function will take the range from the lower limit to the upper limit. 0 is called as the lower limit and 5 is called as the upper limit. Now the range will be from lower limit to upper limit minus 1. That means what will be the possible values in this set? 0, 1, 2, 3 and 4. Why 4? Because the range is from lower limit to upper limit minus 1. Okay. Now at first I will take the value of 0 and it will come inside the loop. What is written inside the loop? Print Alice. So let's assume this is the output screen. So what will come in the output screen? alias will come in the output screen. Now this loop is completed. Now again it will go and check the condition. So now I will take the value of 1 and then it will again come inside the loop. What is written there? Alias. So again alias will be coming, then again condition will be checked. Now 2. So whatever is written within the loop will be executed, that is alias. Then 3 will be taken. So again alias, then 4 will be taken, then again alias. Now at the end also it will again go and check the condition. Now you see that all the values are used up. So the loop cannot run now. So now what will happen? The control will come to the line which is following the loop. That means here if I write something like print high, high will be displayed after displaying the name 5 times, because after displaying the name 5 times this condition will become false, and then whatever is there after the loop, if something is there, it will be displayed. Okay, so if I just write here, whatever I write within the same indentation level, if I write here print, let's say print A here after alias, then as I run it I am getting alias A, alias A, alias A, alias A and alias A, because it is in the same indentation level. But if I just break the indentation and write it from here, then it is a part of the main program. Now you will see the difference in output. Now what will happen? Once the condition becomes false, only then this particular line will be displayed here. This is known as the iterative flow control. Why iterative? Because similar type of tasks are being done again and again. Okay, that's all about the day. I hope you have understood everything. Thank you very much. I'll see you again in the next part. Hello and welcome to the chapter Flow of Control. This is the part 2 of this particular chapter. I hope that you have watched the other parts of this chapter. If not, you can always check out. I have given all the links in the description. So today's topic of discussion is selection statements in Python, and out of the selection statements we are going to discuss about if statement, if else statement and if elif statement. So let's begin with the concept of selection statements. See, till now whatever programs we have been doing in class 11, all the programs executed sequentially. Sequentially means line by line without skipping any line in between. But selection statements are some category of statements which are executed based on a condition. And in this type of statements, not all lines of code gets executed. Some lines of code will get executed and some other lines of code will not get executed. Here, if a condition evaluates to true, a course of action is followed, otherwise a different course of action is followed. And based on the condition, as you will see after a few minutes when I'll be dealing with some practical examples, here there is a condition. If the condition evaluates to true, a course of action is followed, otherwise the condition is ignored and a different course of action is followed. Let's try to understand it with the help of a flowchart. So here, in case of selection statements, in all the categories of selection statements, we'll be having a condition. The condition may be true or it may be false. If the condition is true, a set of statements will be executed, and if the condition is false, then a different set of statements may be executed or the condition may be ignored also. Now let's go and check out the types of selection statements. I hope you have understood how a selection statements work. A selection statement will select only certain specific parts from the entire code. How the selection will be done? Selection will be done based on certain conditions. Now there are basically 4 types of selection statements. They are if statement, if else statement, if elif statement and nested if statement. In today's topic of discussion, we are going to basically discuss about if else, if elif statements. Nested if I'll be discussing in the next part of this particular chapter. Let's go and try to understand about the if statement. Now in case of if statement, there is a condition, and if the condition evaluates to true, the statements in the body of if are executed, otherwise the statement within the body of if is ignored. Now in this category of statements, what happens? Let us try to understand with the help of a flowchart. Now here there will be a condition. The condition may be true and the condition may be false. If the condition is true, then certain set of statements are executed, and if the condition evaluates to false, then the body of if condition, that means whatever will be written within the block of if condition, it will be ignored by the Python interpreter. What is the syntax for using if statement? The syntax is as follows. We give if, after that we write whatever condition needs to be fulfilled, and then what Python interpreter will do, Python will check the condition whether the condition is true or false, and if the condition is true, only in that situation it will go inside that particular block. Now let's go and take an example of an if statement, and let's see how the if statement works. So for that I'll be doing a program which is used to accept three numbers from the users and find the largest of the three numbers. Okay, let me write the name of the program in command. Let me write it. Write a program. Write a program in Python to accept three numbers from the user and find the largest of three. So we'll take three numbers from the user as input, and then we'll find out the largest among the three numbers. So let's take three variables for accepting three numbers. So let's do it. A equals to float input, because the numbers we'll be taking, they are of floating point type. Float input, enter first number, and then I'll give a slash n here, and then I'll receive the second number. B equals to float input, let's write, enter the second number. Okay, and then we'll take the third number. So we'll write C equals to float input, enter the third number. So all the three numbers are received in A, B and C respectively. After that, what we'll do, by default we'll assume that A is the largest number. So what we'll do, we'll take a variable, let's say max equals to, let's say, A. That means whatever you will enter through A, by default it will be assumed as the greatest number. After that, what I'll do, I'll compare the second number denoted by the variable B with the maximum, that is with A. So what I'll write here, if B greater than max, that means it will be checked whether the second number is greater than the first number or not. So, and if it is greater than the first number, then what I'll do, I'll just change the value of max. Now I'll assign it to B. Now if it is false, okay, then I'll give another if statement where I'll check C is greater than max or not. Okay, and even if it is true, then what will happen, max will be assigned to B, and then again this condition will be checked whether C is greater than max or not. If C is greater than max, then what will be done, max will be equals to C. So ultimately by the end of this program, I'll be getting the largest among these three numbers. So what I'll do, where will be the number located? The number will be located in the variable max. So what I'll display here that the largest number is comma max. Now let me run it. At first I'll give, let's say 12, let's say 15, and let's say 7. Okay, and press the enter key. What I'm getting that the largest number is 15. Okay, so let's try and understand how this particular program works. So what we had there, we accepted three numbers from the user by the variables A, B and C respectively. Here A denoted first number, B denoted second number and C denoted the third number. After that, what we did max equals to A. What were the inputs? Our inputs were 12, 15 and 7. So A was your 12, B was 15 and C was your how much? It was 7 in this case. So at first max equals to A. So what was done internally by the Python interpreter? Max equals to A. A means what? A means 12. After that, what was the next line of code? It said if B greater than max. So what was checked? B greater than max. So what is B? B is 15, 15 greater than max, max means 12 now. Is 15 greater than 12? Is it true or false? Yes, it is true. Since it is true, it will go inside the if block. Now what is written inside the first if block? Max equals to B. That means we have a new max. So earlier max will be erased. Now max equals to B. What it means? It means that max equals to B means the second number, that is 15. Now what Python interpreter will do? It will go for the second if condition where it is written if C greater than max. So now what will be checked? C greater than max. It means what is the value of C? C means our 7. 7 greater than max. What is max? 15. Is 7 greater than 15? No, it is not. Therefore the condition is false. So this particular part, the second, inside the body of the second if statement, whatever is written, it will be ignored. So finally, and it will break and come out of this if selection statements. So finally what we have at the variable max? We have the largest number as your 15. So what will be displayed? The largest number is comma max. What was the value stored at max? The value stored at max at the end of this program is 15. So it is being displayed that the largest number is 15. Let me run it again with different set of inputs. Let's give 98, 43 and let's give 165. As I press the enter key, now I'm getting that the largest number is 165. So in this way the if statement runs. It is based upon a condition. If the condition is true, the statements within the body of if statement within the same indentation level will be executed, otherwise it will be ignored. That's about the if statement. Now let us go to the next concept or the next type of selection statement, that is the if else statement. Now in case of if else statement, if the condition within if, there are two things here, if and else. If the condition within if evaluates to true, then the statements in the body of if are executed. Otherwise, the statements within the body of else are executed. So if the condition is true, whatever is written within if, it will be executed, and if it is false, then whatever is written within the else statement, it will be executed. Now it is used when there are two situations in a particular program. Now in case of two situations, you will be using if else statements, and out of the two situations, one situation definitely must be true. Let's try to understand with the help of a flow chart. So there will be a condition. If the condition is true, then body of if will be executed. That means whatever is written within if, it will be executed. And if the condition is false, then the body of else will be executed. That means whatever is written within else, it will be executed. So what's the syntax? The syntax is as follows. If under if we give a condition, if the condition is true, whatever is written within if, it will be executed, and if the condition is false, then whatever is written within else, it will be executed. Remember, it is used when there are only two situations in a program, and out of the two situations, one situation will work based on a condition and the other situation will execute if the first situation evaluates to false. Now let's go and do a practical example related to the if else statement. So what we'll do, we'll just take a number from the user and check whether it is odd or even. So let's quickly do it. Write a program in Python to check whether a number is even or odd. Okay, so we'll take a number from the user and it will display whether it is even or odd. Okay, so what I'll do, I'll take a variable, let's say n. So let's check for this numbers, integers only, positive integers only. So let's take int input. Here I'll give enter a number to check for even or odd. Now what we'll do, now how can you determine whether a number is even or odd? Now if a number gets divisible by 2 completely, then it is an even number, and if it does not get divisible by 2 completely, that means if it has a remainder at the end, then we say that it is not divisible by 2 and therefore it is a odd number. So how we'll check? We'll check in this manner. If n means the number, modulo divide 2 equals to 0. That means here what I am checking, here I am checking the remainder. This modulo divide, it finds out the remainder. Now if the remainder is 0, that means what we can declare? We can declare that the number entered is even. Now there are only two options, either even or odd. So here it's better you use the else statement. Here else statement does not require any condition, so within else will be giving the number entered is what? It is odd. Okay, let me save it and let me run it. It is asking me enter a number to check for even or odd. Let's say I gave 8 and press the enter key. It is displaying that the number entered is even. Again, let me run this program, enter a number to check for even or odd. Now let's say I'll give 17 and press the enter key. Here what I am getting? Here I am getting the number entered is odd. Now let's see how this program worked, or how did this program executed. So for that, so at first we took a variable n, and in this variable we received an input. So at first let's say I received the input as 8. After that what we did, we checked if n modulo divide 2 equals to 0. So what we checked? We checked n modulo divide 2 equals to 0. It is true or not. Now let us check. N means what? 8. 8 modulo divide 2 equals to 0. Now how this operation takes place? We'll have to divide 8 by 2. So we are getting the quotient as 4 and remainder as 0. Now this particular symbol, it takes out the remainder. What is the remainder in this case? The remainder is 0. Now is 0 equals to 0? Yes, 0 is equals to 0. That means it is true. Now since the condition is true, within that condition I have written the number entered is even. Why I have written like that? Because if a number gets completely divisible by 2, there is no remainder, and therefore we can declare that the number entered is even. Therefore we are getting through the output screen that the number entered is even. Let's say in place of n I am giving 7 now. So n modulo divide 2 equals to 0. N means what? 7. 7 modulo divide 2 equals to 0. So if I divide 7 by 2, I'll get the remainder as 1. But is 1 equals to 0? No, 1 is not equals to 0. Therefore we have declared in the second case that the number entered is odd. So in this case the condition will become false. Since the condition becomes false, what it will do? It will immediately go to the else block and execute the statements which are within this block. Here I have given equal to and not a single equal to, because single equal to is called the assignment operator. But if you want to compare for left hand side equals to right hand side, then you have to use double equal to symbol. I've already said that in the previous classes, but still just for revision I'm saying it again here. So this particular program runs in this manner. Now let's go to the next type of selection statement, which is the if elif statement. Now how does if elif statement runs? Let us try to understand. Now here, as you can see, at first the program will begin and then the condition will be checked. This is the condition, if condition. Now if the condition is true, then whatever is written within the if condition, that means the body of if, will be executed. The condition may be false also. If the condition is false, then then we have another statement called as the elif statement. Then within Elif also will have a condition. That condition is checked. If that condition is true, whatever is written within Elif, it will be executed. If that condition is false, then whatever is written within the body of the else statement, it is used. Remember, if Elif statement is used if there are more than two conditions. Okay, so let's say there are 5 conditions. So in the first condition, we'll have to write if. In the second, third and fourth, we have to write Elif, and in the last condition, that is in the 5th condition, we have to write else here. So in this way, the if Elif statement, selection statement is implemented. So this is the flow chart for that purpose. So here what can be said, it is used in situations where there are more than 2 conditions. So in case of more than 2 conditions, we'll use the if Elif statements. So what is the syntax? The syntax is as follows. We'll give if, after that the condition, and if the statement within the condition is true, then whatever is written within that, it will be executed. Otherwise, Elif, under Elif also there will be some conditions, and if the state condition within Elif is true, then it will be executed. Otherwise, it will go to the else parts. Okay, in this way, if Elif statement generally works. Now for better understanding of if Elif statement, let us do a particular program. Now what is the aim of the program? Let us check out here. Okay, so let's say here what we'll do, a student will enter the percentage. P stands for percentage, and based on the entered percentage, the result will be displayed. Either the student secured first division or second division or third division, or he failed. So what we'll do, we'll take, if the percentage is between 60 and 100, it is first division. If the percentage is between 50 and 60, then second division. If it is between 40 and 50, then it is third division. And if the student gets lower than that, then the student will fail. Okay, so let us go and implement this. Now here how many conditions are there? 1, 2, 3, 4 conditions are there. Therefore, it's better if we use if Elif statements. Now let's go and use it for finding out the division or the grade of a student based on the percentage enter. So let me write the name of the program, which is write a program in Python to calculate the grade obtained by a student based on percentage entered. Okay, so what we'll do, we'll take the percentage from the user. Let's take it by the variable p equals to, let's take it as float. Why float? Because a student may get 86% also or 86.5% also, so that both the values can be accommodated. Therefore, it's a good practice to take float in these situations. Okay, so we'll take the this one percentage from the user. So here we'll write enter the percentage. Let's do it. After that, what I said, if the percentage is within the range of 60 and 100, that means if the percentage is greater than or equals to 60 and percentage is less than 100, this condition, the second condition also you have to give. Percentage should be greater than or equal to 60 and less than 100. Then, or we can give less than or equals to 100 also we can give. So what we'll write here, print you secured first division. Next, let us give Elif. If percentage is between 50 and less than 60. Okay, less than 60, why I have not given equal to here? Because if p is equal to 60, then it will come under the first block. So as to avoid conflict, I am giving here P less than 60. Okay, so here I'll be printing U secured second division. Okay, now we have another condition. So if I give Alif, okay, P greater than equals to 40, that means between 40 and 50%, I'll write here like U secured third division. Okay, now if this is also not true, then what I can say? I can say that the student failed. So else I can just write here print the sorry you failed. Done. Now let us run this program. Okay, very simple. If there were how many situations? 4 situations. Out of that, the first situation and last situation will be if and else respectively, and for all the middle situations you will have to give elif along with the conditions. So if I run it, it is asking me to enter the percentage. Let me give it as 54. It is showing me you secured second division. Let me give it as 86.2. It is giving me you secured third division. Let me give 23.2%. It is giving me sorry you failed. Okay, so if I just run it and let's give it 143%, then also it is giving me sorry you failed. But is it a right output? No, it is not a right output. Therefore what we can do, we have to this one give situations for this boundary conditions also. So for that, how you can give? You can give in this format. We can give here like after this elif, we can just give here elif. If we give percentage less than 0, okay, if someone gives percentage less than 0 and percentage greater than 100, then we can give print invalid input. Okay, because sometimes while entering the percentage, the students or parents, they might make some mistake. Therefore, for handling it efficiently, this invalid input has been given. So if I just run it, now if I give the percentage as 143, I am getting sorry you failed. Why I am getting sorry you failed? Yeah, okay, if percentage greater than 100, I'm getting, okay, let me just do one thing. I'll just give the condition here. Just let me do like this. Elif percentage your between 40 and less than 50. If I give if percentage less than 40 and percentage greater than, if percentage I can give like this, if percentage greater than equals to 0 and percentage less than 40, you can give sorry you failed. If these conditions are not fulfilled, it will be a better approach. I'll give here print invalid input. I can write in this manner. So let me run it and let me give the percentage as 143. What it is giving me? It is giving me invalid input. That means percentage, the greatest value of percentage can be 100%. Okay, it cannot be more than that. Therefore I am getting invalid input. Why invalid input? Because while checking, at first this condition will be checked. All of you know how AND operator works. I have already explained it in the chapter of Python fundamentals and the chapter on data handling in Python. You can just check it out. And after that, the second condition will be checked. If it is false, then third condition. If it is false, then the fourth condition, and if this is also false, then it will come to the last condition. Let me run it again and give the percentage as -5. -5 is also not accepted, therefore all these conditions will become false, and finally I'll get the output as invalid input. Okay, so in today's session we have discussed about if, elif, and if else and if elif statements. That's all for the day. I hope that this session was useful. Thank you very much. Now in elif, one more thing, in elif there can be as many conditions as required. Okay, I hope that this session was useful. Thank you very much. Hello and welcome to the chapter on flow of control. This is the part 3 of this particular chapter. I hope you have watched the other parts of this chapter. If not, I have given all the links in the description. You can go and check out the other parts. So today's topic of discussion is nested if. As you already know, we were discussing about selection statements in the part 2 of this particular chapter. Within selection statement, we discussed about if statement, if else statement, and if elif statement. Now this is the fourth type of selection statement, which is called as the nested if. So let's begin with the concept of nested if. So before going to the programming aspect of nested if, let us try to understand the meaning of the word nested. Nested means if something is contained within a different thing, then we say that it is nested. For example, let's say we have a container here. So what is this? Let us name it as container 1. Now within this container, if I put another container, let's name it as container 2, then what we will say? We will say that container 2 is nested within container 1. So basically the basic meaning of the word nested is that if there is something within a different thing, then it is said to be nested. So let's see what is the meaning of the word nested, which is being used with respect to Python programming language. So let's, going by the definition, we have that a nested if is an if that has another if in its if's body, or in its elif's body, or in its else body. Don't worry, the definition looks very confusing. Therefore, let us try to understand it with the help of some blocks of code. Let's try to understand the first part of this particular definition. First part says that if within a single if statement we have another if statement, that means if within one if statement, if we have another if statement, then it is known as nested if. Also, if within elif we have an if statement, then also we say it to be nested if. Why? Because one statement or one block is contained within another block. Similarly, going by the third part of this definition, if within else, if we have another if statement, then also we say that it is nested if. So summarizing this, what we can say that if within one if statement, or within elif statement, or within else statement, if we have another if block, then it is said to be nested if. So we are going to implement nested if for solving the quadratic equation. So how I will show you the practical applications of nested if. I'll show it to you with the help of a program. The name of the program will be a quadratic equation solver. So we'll be designing a quadratic equation solver, and this particular program will also have the capacity of finding out the nature of the roots. So before going to the actual problem solving using Python, let us revise a little bit about the concept of quadratic equation. As you have already studied in your lower classes, what is a quadratic equation? An equation which is in the form ax squared plus bx plus c is known as a quadratic equation. There is a condition for quadratic equation. The condition is that a is not equals to 0. This particular equation, it is known as the general form of a quadratic equation. Now, how to solve a quadratic equation? A quadratic equation can be solved using three different methods, which are method of factorization, method of completing squares, and by using quadratic formula. Here in Python, we are going to solve the quadratic equation using quadratic formula. So let us revise what the quadratic formula says. The quadratic formula says that if a quadratic equation is in the form ax square plus bx plus c, where a is not equals to 0, then we can find out the roots of the quadratic equation as follows. X equals to minus b plus minus root over b square minus 4ac by 2a. Here we have two roots because I have written here plus minus. So what we can do, we can extract the two roots from here. Let's name the first root as r1. So we can write r1 equals to minus b plus root over b square minus 4ac by twice a. What will be the second root? Let's name it as r2. r2 equals to minus b minus root over b square minus 4ac by what? By twice a. Always remember, in case of a quadratic equation, you will get two roots. What is the meaning of the roots? Roots means the results which we get after solving quadratic equation, they are referred to as roots. Here you can see one thing, which is b square minus 4ac. If you just revise the previous concepts of mathematics, you will find that b square minus 4ac, it is known as discriminant. Okay, let us denote discriminant by the alphabet D, and based on the discriminant you will get a particular quality of the roots. If discriminant is greater than 0, the nature of the roots will be real and unequal. If discriminant equal to 0, then nature of the roots will be real and equal. And if discriminant less than 0, the nature of the roots will be complex and imaginary. Okay, so what will be the main purpose of our program? The main purpose of our program will be to solve a quadratic equation and then finding out the nature of the roots. So what is the this general form of a quadratic equation? It is ax square plus bx plus c, where a is not equals to 0. It is called as a quadratic equation. So in Python program, we'll be receiving a, b and c from the user. Why? Because that's what is required in the right hand side of the formula for finding out the roots. After receiving a, b and c, we'll have to check whether a is 0 or not. If a is 0, we'll terminate the program then and there. But if a is not equals to 0, we'll go on solving the quadratic equation, finding out the roots of the quadratic equation and also displaying the nature of the roots. Now let's go back to the Python program and solve it. So our purpose will be to make a quadratic equation solver and finding out the nature of the roots. Okay. Now in the quadratic equation formula, the formula says that minus b plus minus root over b square minus 4ac. Now for giving root over in the Python programming language, we have a function called sqrt, which is within the math module. So what we need to do, we need to import the math module at the very beginning. For knowing more about modules, you can check out my video on introduction to modules. So import math. So we need to import the math module for sqrt function. That means for giving the square root. Also, in case of complex roots, math module is unable to help. So for complex root, what we require a different module called cmath. So we'll import the module cmath also. Cmath is required for complex root. After that, the general equation of quadratic equation is ax square plus bx plus c. So we'll be receiving a, b and c from the user. So at first let us receive A. Let's receive them in integer format only. A equals to int input. Let me write, enter the value of A. Then let us receive B. B equals to int input, enter the value of B. Then let us receive C. C equals to int input, enter the value of C. Okay, got it? Now there is a condition for an equation to be quadratic. The condition is that A should not be equal to 0. So let us filter out that condition. So for that, what we'll do, we'll check whether A is 0 or not. So how to check? If A equals to 0, about the if statement I have already discussed in the previous part. If it's not very clear, then you can just revisit the previous part before going through this particular part. So if A equals to 0, what we can do, we can display that the equation is not quadratic. Okay, so here we can give a slash and extra slash n. Okay, but if A is not equal to 0, we can continue to solve the quadratic equation. So if A is equals to 0, so for that we'll be putting here else. Now within else, what we will do, at first let us find out the discriminant. What is the formula for discriminant? The formula for discriminant is b square minus 4ac. How to write it in Python? We can write it as follows: b into b minus 4ac. 4ac we write in mathematics in this format, but here the multiplication is not understood. You have to give it explicitly. So I have to give here 4 into a into c in this manner. Let us keep it in a variable, let's say d. So now at first what we'll do, we'll find out the discriminant. So d equals to b square, we can give b into b minus 4ac, 4 into a into c. After finding out the discriminant, based on the discriminant only, the nature of the roots will change. So what I can do, I can filter out the first condition. The first condition was that if discriminant is greater than 0, the nature of the roots are real and unequal. Now if discriminant is greater than 0, let us find out the roots. Let's name the first root as r1. r1 equals to, what is the formula? Minus b plus, this is the first root, and square root of b square minus 4ac. How to give the square root? By calling the sqrt function, which is within the math module. So we'll write minus b plus math dot sqrt b square minus 4ac. But b square minus 4ac we have already assigned it to the variable d. So we'll put here what? We'll put d here, divided by twice a. So I'll write here 2 into a. After that, let's find out the second root. r2 equals to minus b. Now the second root consists of minus math dot sqrt d divided by twice a, 2 into a. Okay, so in this way we can find out the roots. After finding out the roots, we can display the nature of the roots. So roots are real and unequal. Why? Because if discriminant is greater than 0, we can say that the roots are real and unequal. Now let us display the roots. Let's display the roots like as follows. Roots are comma r1 consists of the first root, and let's display the second root, which is stored in the variable, which one? Which is stored in the variable r2. Now let's go to the next condition, which is elif d less than 0, not less than 0, let's filter out d equals to 0. In the previous class, I have already said that if there are more than 2 conditions, here we have 3 conditions, we have to use if elif statements. Now here why it is called as a nested if? Because within else we have used another if block. Therefore, since we are inserting if block within else, therefore this if is called as nested if. Now let us find out the roots. The finding out the roots, it will be similar. So let me just copy paste these two lines and let me just paste it here because it will be similar. After that, let me display the nature of the roots. In this case, the nature of the roots will be what? The nature of the roots will be real and equal. So let's display it like roots are real and what? They are equal. Okay. Now let us display the roots. Print roots are, the first root is what? It is R1 and the second root is R2. So let's display R2 here. So our second condition is also complete. Now let us go for the third condition. Okay, now we'll go for the third condition. There is a problem here. Yeah. Okay. Wait, let me just reopen it. The software crashed, I guess. Yeah. So we have filtered out how many conditions? We have filtered out 2 conditions. Now we are left with the third condition. Okay, so let's implement the third condition here. So do I have the program? Let me just check out the program. Okay, yeah, this is the program. So the first 2 conditions we have already done. After that, what we'll do, we'll go for the last condition, which is, now see, there are only 3 conditions. Either discriminant can be greater than 0, equal to 0 or less than 0. It will come in the third else statement if discriminant is less than 0. So what we'll do, we'll find out the roots here. So for that, let me just copy it and paste it here. After that, in this case, the roots will be what? The roots will be complex and imaginary. So in this case, let us write roots are complex and, oh, this crashed again. Let me just try it again. Just a minute, I'm finding some problems here. Okay, so after finding out the roots, let us display that the roots are what? Imaginary and complex. Okay, now let us display the complex roots. Now here one thing is changed here. What is changed? Instead of math, we are writing C math here. Okay, why C math should be written? In the previous 2 conditions we have written math, but here we have written as C math because in the third case the roots are complex. For complex root we will not write math.sqrt, rather we will write cmath.sqrt. Okay, that's the only difference between complex roots and real roots. So now let us display the roots. For displaying, the rule will be same. Roots are, let's say, R1 and comma R2. Okay, that's all about the program. Now let me just save this program and run this program. So it is being displayed quadratic equation solver because I have written quadratic equation solver at the very beginning. Now it is asking me for the value of a. All of you know the general form of quadratic equation, which is ax square plus bx plus c. Now it is asking me to enter the value of a. Let me enter the value of a as, let's say, 1. B, let me enter as 5. C, let me enter as 2. Now if you calculate b square minus 4ac from here, just calculate it mentally. 5 square is how much? 25. 25 minus 4 into 2, which is 8. So 25 minus 8 obviously will get a value which is greater than 0. So this condition is true. So as I press the enter key, what I am getting? Roots are real and unequal. Okay, here I have used another one thing, okay, which is round. What does the round function do? Round function will round off the number, the answer, to the required number of digits. Here what I have written, round r1 comma 2. That means after the point only 2 digits will be kept here. Okay, so roots are real and unequal. Let me run it again for the second case. This time let's take the value of a as 1, b as 2. Let's take the value of c as 1. Now what we are getting, roots are real and equal. If you just solve b square minus 4ac, you will find that discriminant equals to 0. So in that case, what is the nature of the roots? Nature of the roots are real and equal, and here the roots are being displayed. Okay, that's the second case. Let me run it again and take values such that it falls under complex roots. So let's take value of a as, let's say, 5. Let's take value of b as 1. Let's take value of c as 2. Now we are getting discriminant less than 0. Therefore, it is falling under the last else condition, which says roots are imaginary and complex, and the complex roots are being displayed. Remember, in case of complex roots, you have to use cmath.sqrt, not math.sqrt. Here, in which part nested if has been used? Nested if has been used in this particular part. Okay, why it is called nested? Because it is contained within a different block. Under which block it is contained? It is contained within the else block. In this way, you can apply nested if to where within one condition, if you have multiple conditions, you can take the help of nested if to arrive at your result. That's all for today. I hope that this session was useful. Thank you very much. Hello students, welcome to the chapter on flow of control. This is the part 4 of this particular chapter, and today we are going to discuss about iteration statements in Python. And out of iteration statements, basically we'll be focused on the loops. Those are for loops and while loops. I hope that you have watched the other parts of this chapter. If not, I have given all the links in the description. You can just check out the description box for the same. So let's begin with the topic for the day, which is iteration statements in Python. So at first we need to understand the meaning of the word iteration. Iteration means something which is repetitive in nature. So what are iteration statements? So what happens in this case? In this case, a statement or a group of statements are repeated depending upon a condition. So in case of iterative statements, there will be some conditions or there will be certain range of values, and depending upon the condition or the range of values, a group of statements will be executed. The statements are repeated until the condition evaluates to true, and it stops once the condition evaluates to false. Now there will be some conditions in case of iteration statements. If the condition evaluates to true, then what happens? The set of statements within that particular block will be executed, and if the condition evaluates to false, then those set of statements are ignored. Let's try to understand it with the help of a flowchart. Also, I would like to say that iterative flow controls, the statements within the iterative flow controls, these are also known as looping statements. So let's try to understand it with the help of a flowchart. So what we will have in case of iterative flow control, we will basically be having a condition. Now the condition may be true, the condition may also be false. If the condition is true, then a set of statements are executed within that block. Okay, now after the set of statements within the block are executed, then again the condition is checked if the condition is still true or not. If the condition is still true, then again this set of statements will be executed. Basically, this set of statements will be executed till the condition becomes true, and after a certain set of statements are executed, again the condition is checked. Now a time will come when the condition will become false. As the condition becomes false, what will happen? It will exit from the loop when the condition becomes false, and no longer the statements within the condition will be executed. Remember, two cases: if the condition is true, the statements within that condition will be executed, and after the end of the statement the condition is checked again. If it is still true, then again those set of statements will be repeated, and one point will come when the condition will become false. As the condition becomes false, the loop will be exited. Now we need to know about a certain category of statements before trying to understand about iterative statements practically. So the first type of function that we need to know is the range function in Python. So what is range function? This function is used in Python to generate a list of a sequence type. Now if you want to generate a list of a particular sequence, then what you will do, then you will basically be using the range function. Okay, so this function is used in Python to generate a list of a particular sequence type. What is the syntax for range function? The syntax is range, lower limit, comma, upper limit. You will be understanding better when we go for the practical part. In this video only we will go for the practical part, so keep following. Now range, the syntax is range, lower limit, comma, upper limit. Here L denotes the lower limit and U denotes the upper limit. Condition is that the lower limit and upper limit, both of these must be integers. So what does the range function does? The range function will generate a list of integers from lower limit to upper limit minus 1. That means if I write range 2, 10, then the set of integers will be 2, 3, 4, 5, 6, 7, 8 and 9. That means one less than the upper limit will be executed. For example, if I write range 0, 6, it will generate the list of values 0, 1, 2, 3, 4 and 5. If I write range 6, 0, it will generate an empty list. Empty list, why? Because it cannot move in the backward direction naturally. It will always try to move in the forward direction. If I write range minus 6, minus 1, this is also possible. What will be the set of values in this case? The set of values will be minus 6, minus 5, minus 4, minus 3 and minus 2. If I write range 5, it will generate the list of values 0, 1, 2, 3 and 4. Now let's go and try to implement it in Python. Now if I want to see the list of values within a range, if I directly write range 0, 6, it will not give you an output, but if you want to see the range of values that will be accepted, then you have to put it within the list function. So if I write list range 0, 6, then it will give you the list of values which will come within this range, that is 0, 1, 2, 3, 4 and 5. Remember, 0 is the lower limit, 6 is the upper limit, and it always generates a value 1 less than the upper limit. If I write list range 6, 0, that means I am trying to move in the backward direction, but this is not possible in the general case. It is possible if I use the step value, but if I do not use any step value, then this particular thing is not possible. If I can even use negative values also. If I write minus 6, minus 2, then I'll get the values minus 6, minus 5, minus 4 and minus 3. So basically, what is the use of range function? Range function is used to generate a list of values. Let's move ahead. Now the second case of range function is range with step value. Sometimes we might want to skip certain values in between. If we want to skip certain values in between, then we will take the help of step value. So this function is used in Python to generate a list of a sequence type by taking step value into account. Okay, so if you want to take the step value, when is the step value used? Step value is used if you want to skip certain values while dealing with the range function. What is the syntax of this? The syntax is range, lower limit, upper limit, step. I'll try to explain you with the help of some examples. So L denotes lower limit, as in the previous case, U denotes the upper limit and step denotes the step value. That means by what factor will it skip. For example, if I write range 1, 10, 2, here 2 is the step value, therefore 1 gap will be there in between. That means the list of values to be generated are 1, 3, 5, 7 and 9. Why there is a gap of 1 in between? Because here we have used the step value as 2. If I write 9, 3, minus 1, here I am trying to move in the backward direction, but it is possible in this case because you have used the step value as minus 1. So the list of possible values will be 9, 8, 7, 6, 5 and 4. Similarly, if I write range 10, 1, it will generate 10, 1, minus 2, it will generate the values 10, 8, 6, 4 and 2. Remember, you can move backward also if you are using a negative step value. Okay, so now let's try to implement it in Python programming language. So if I write list range 1 comma 10 comma 2, here 2 is the step value, therefore 1 gap will be there after each number. So the possible values are 1, 3, 5, 7 and 9. We can even move backward if I write like this way, like list range 10 comma like 1 comma minus 2. Then it will generate the list of values 10, 8, 4, 10, 8, 6, 4 and 2. Let's move ahead with the next concept, which is the in operator in Python. Now, what is the usefulness of in operator? In operator is used to check whether a particular value is contained in a sequence or not. Okay, so this operator is basically checks whether the value that you want to search is present in your sequence or not. It returns true if a value is contained in a sequence, false otherwise. If the value is present in the sequence, then it will return true, otherwise it will return false. Let's see what's the syntax of the in operator. The syntax is value in the sequence you will give as in the list format separated by commas. Now if I write 5 in 8, 4, 8, 3, 4, 5 and 21. Now is 5 present in the list? Yes, 5 is present in the list. Therefore, it will give you the output as true. If I write 55 in 8, 3, 4, 5 and 21, is 55 present in the given list? No, 55 is not present in the given list. So it will give you the result as false. It works with strings and tuples also, not just with integers. If I write ji in Abhijit, is the string ji present in the string Abhijit? Yes, ji is present in the string Abhijit. Therefore, it will generate the result as true. Similarly, if I write lm in Abhijit, the string lm is not present together in the string Abhijit. Therefore, it will generate the result as false. If I use a tuple here, if I write 5 in 8, 3, 4, 5 and 21, here I have used a tuple. How can you come to know that I have used a tuple? Because I have used the first bracket in this case. Therefore, I'll get the result as how much? I'll get the result as true. Let's quickly implement it in the Python programming language. So if I want to check if 5 is present in a particular list, I'll give 5 in. Now let's say the list of values are these. Okay, now is 5 present in this list? Yes, 5 is present in this list. Therefore, I am getting true. If I write 55 in, let's say 9, 12, 5, 22, then it will generate false. Why? Because 55 is not present in this particular list. It is also possible to check for tuples and strings also. Let me just show you with string. If I write ji in Abhijit, now here you can see that the string ji is present within the string Abhijit. Therefore, it will generate the result as true. If I just write, let's say ZH, it will generate false because ZH is not present together in the string Abhijit. Okay, now let's see the reverse operator of the in operator, which is the not in operator in Python. The not in operator is used to check whether a particular value is not contained in a sequence or not. It will do the exact opposite of the in operator. It will check whether a particular value is not contained in a sequence or not. If it is not contained, it will return true, and if it is contained in the sequence, then it will return false. What is the syntax? The syntax is value not in a particular list. For example, if I write 5 not in 8, 3, 4, 5 and 21, here 5 is present in this particular sequence, therefore it will return you false. If I write 55 not in 8, 3, 4, 5 and 21, yes, 55 is not present in the list. So if a value is not present in the given list, then it will return the result as true. It also works with strings and tuples. For example, if I write ji in not in Abhijit, ji is present in the string Abhijit, therefore it will return false. If I write 5 not in the given tuple, 5 is present in the tuple, therefore it will return false. That means if a particular value is present in the list or tuple or string, then it will return false. If it is not present, only in those cases it will return true. For example, if I write 5 not in, let's say 3 2 6 5, then it will return false because 5 is present in the sequence. Here if something is present in the sequence, then it will return false. Similarly, if I write ZH in Abhijit, ZH is not present in Abhijit, therefore it will return what? Oh sorry, I have to give not in. ZH not in Abhijit, yes, GH is not present in the string Abhijit, therefore as I press the enter key, I am getting the result as true here. Okay, that's about the in and the not in operator. Now till now we have learned about three concepts, the concept of range, in and not in. Now we are ready to go for the looping concepts. Now before that, let us discuss the categories of loop. There are basically two categories. The first category is the counting loops. What are counting loops? So the type of loops that repeat for a certain number of times are called counting loops. Okay, so if a loop repeat for a particular number of time, then it is known as counting loop. For example, for loop is a category of loop which falls under counting loops. Second category of loop are the conditional loop. This type of loop repeats based upon a particular condition. If the condition is true, then a particular group of statements are repeated. The statements are repeated until the condition becomes true again and again. Don't worry, I'll explain all this with the help of some practical Python code after a few minutes. Now, example of conditional loop is the while loop. So let's discuss about this categories of loops. So the first category of loop is the for loop. This type of loop is designed to process the items of a sequence. Now if you have some values in a particular sequence, for processing those items in a sequence, we use the category of loop known as for loop. What is the syntax for loop? The syntax is for variable in sequence, then we'll write statement 1, statement 2 up to statement n. Okay. Now let us try to understand for loop with the help of an example. Now when are looping statements used? Looping statements are basically used when we want to repeat a set of statements for a given number of times. Let's say I want you to print your name 5 times. So how you will write? You will just write print, then your name. Let's say your name is Alice. You will write the print statement how many times? You will write the print statement 5 times. Okay, I'll write print Alice, print Alice. As you can see, it is taking a lot of time unnecessarily. Why unnecessarily? Because I am doing the same tasks again and again. Now if you are doing same tasks again and again, then you can put it under automation. So if I run, what I'll get that the name is printed 5 times. Now instead of doing this, I can just do it in only 2 lines. How to do it? Just use the concept of for loops. Let's see the syntax of for loop. What is the syntax? The syntax is for variable in sequence. So we'll give any variable for, let's say I'll give the variable I, in, I'll give range. Let's say I want to print my name 5 times. I'll give range 0, 5. Let's write something here. Let's write a string called hi. If I just write hi here, and if I just run it, you will see that the word hi has come 5 times. Now the question is how this particular code is working. Now let's try to see how this particular code is working just with 2 lines. So for that, I'll just go to my board and I'll just see how this particular code is working. So my code is for I in range 0, 5. Here I have written print hi. Okay. Now here we'll see what does this particular statement means, range 0, 5. Now as we have already seen, range 0, 5 will generate the list 0, 1, 2, 3 and 4. What will the in operator do? In operator will check the list of values. Okay. Now what is written here? For I in range 0, 5. That means at first I will take the value as 0 and it will come inside the loop. This is the statement which is present inside the loop. Let's say we have an output screen here. Let's say this is the output screen. Now in the output screen, what will be written? Hi. After that, I will take the next value which is 1 and it will come inside the loop. What is written inside the loop? Hi is written, so hi will be printed here. Then this particular variable I will take the next value which is 2, therefore, and it will come inside the loop and it will print hi. Then it will take the value as 3, then again it will come inside the loop and it will print whatever is there within that particular block. Hi is there, therefore hi will be printed. Then finally I will take the value as 4, then again it will come inside the loop and what is present here? Hi is present here, so hi will be displayed here. Now you can see the entire values of I within the range is being used up. As it is used up, it will come out of the loop. Therefore, you are seeing that the string hi is being displayed 5 times. Now, for confirming that it will come out of the loop after printing 5 times, let us do one thing here. So, here as I have run this code, I have got the answer as the string hi has been displayed 5 times. Now, how to verify that after displaying it for 5 times it will come out of the loop? For that, what we will do, we can just break this particular block and write something here. We can write end. Okay, we can just write any string here, and if I just run it, you will see that after writing for the 5th time hi, it has come as end. Because why it has run for 5 times? Because I have used range 0, 5. Range 0, 5 means what will be the possible values? The possible values will be 0, 1, 2, 3 and 4. Okay, so this is the working of the for loop. We will see many more examples with the for loop, but this part is intended basically to give you a brief idea about the working of all the categories of loops. Now let us go to the next category of loop, which is the while loop. What is while loop? While loop is a conditional loop. What it does, it repeats the instruction as long as a condition remains true. Now once the condition becomes false, this loop will not execute. After a while loop is executed, for an iteration the condition is tested again. Okay, so at first there will be a condition. If the condition is fulfilled, it will come inside the loop, and inside the loop, after running those statements, again the condition is tested. If the condition is true again, then again those set of statements will be executed. I'll explain it to you in a better way with the help of some practical Python codes. The loop ends when the condition evaluates to false. A time comes when the condition evaluates to false. Whenever the condition evaluates to false, the loop will terminate. What is the syntax for while loop? The syntax is this. Initialization value, while condition, then we'll have a group of statements, and finally we have a update condition. So for understanding it better, let us go through a particular Python code. Now if I ask you to add two numbers using Python, I hope all of you know about this. If not, you can just check out my previous videos I have shown you. So for that, I can just use the input, int input. Let's receive the numbers. Let's say I'll receive the first number at the beginning, enter the first number. Okay, then I'll receive the second number. Let's just write it in this manner. Int input, enter the second number. Now let's take another variable z, and I'll write z equals to x plus y. Very simple. Now I'll just display the sum. Print sum is comma z. I'll just save it and run it. As I run it, what it is asking me? It is asking me enter the first number. Let's say I'll give 5. then enter the second number, let's say I'll give 2, and then it is displaying me the result that it is sum is 7. If I want to run it again, then again I have to, if I want to execute it again, then I have to again press on the run button. Then again it will ask me enter the first number, let's say this time I write 2 as the first number, let's say I'll give 9 as the second number, it is giving me the sum as 11. If I want to run again, then again I have to press the run button. But what we can do, we can make this asking whether the user wants to run again or not, we can do it automatically using while loop. For that, let us go through the syntax. The syntax says that we'll have a initialization value. So just before this program, we'll give a initialization value. Let's say I'll give ans equals to y. Okay, you will understand what is meaning, what is meant by the initialization value. Initialization value means the very first value of the loop. After that, I'll write while ans, while condition. The syntax says that now I have to give while and then I have to give the condition. Now, what is the condition that we will give? We will give while ans equals to small y or ans equals to capital Y. That means until this condition is, till this condition is true, then this particular lines of code will be executed. So what I'll do, I'll just put it within a block. How to put it within a block? I have just given a tab here so that everything is maintained within the same indentation level. Now after that, at the end, if I just look at the end of the syntax, what is present there? The update condition is present over here. So what we'll write here? We'll write the update condition here. That means here we will ask the user if the user wants to run the program again or not. Now, in what variable have we taken the initialization condition? Initialization condition we have taken in the variable ans. So let's write ans equals to, as it is a string, I'll just take input. Do you want to run the program again? Let us just ask this to the user, and I'll just give a prompt like y/n. Okay, and we are done here. This is known as the update condition. Now let me run it. It is asking me enter the first number, I'll give 2. Enter the second number, let's say I'll give 7. It is giving me sum is 9. After that, it is asking me, do you want to run the program again? I have to press y or n. If I press y, then again this particular lines of code will be executed. Then it is asking me the first number again. This is without terminating the program. It is going on running continuously. Let's give the first number as 1. Let's give the second number as 7. It is giving me the sum as 8. After that, it is asking me again, do you want to run the program again? Yes or no. Let's say I press n here. So it will terminate the program and it will not run the program again. Now let us try to understand how while loop is working. So for that, let me just take you through the board. At first, what we had ans equals to y. Okay, that means answer we have initialized to y. What is this? This is the initialization. Okay, initialization means this is the first value. After that, what we have, if ans equals to y or ans equals to capital Y, why I have given small y or capital Y? Because at the prompt, someone might give capital Y also, so that it runs even up for capital Y. Therefore, I have used the OR operator here. Now, what is ans? Ans is y. That means the condition is true or false. The condition is true. Since the condition is true, this set of statements will be executed. So it is asking me the first number. Enter the first number. Let's say I'll give the first number as 3. Then it will ask me to enter the second number. Let's say I'll give the second number as 2. Then what is being done? Z equals to x plus y. X is 3, y is 2. So 3 plus 2 is 5. 5 is stored in the variable z, and what will be displayed here? Print sum is z. So what I'll get? Sum is z. What is z? Z means 5. After that, what it is asking me, do you want to run again? Because I have used the input statement here. So what will come in the output screen? It will come, do you want to run again? Yes oblique no. If I press y, then what will happen? It will, no matter I press y or n, it will go and check the condition again. Now if I press Y, the condition is true even now, therefore this set of statements will run again. In the next run, also after running these codes, it will again ask whether I want to run the code again or not. If I press Y here again, then again this condition will become true and it will continue running till you keep on pressing Y. Now the moment you press N or any other key, then this condition will become false, and once this condition becomes false, the loop will be terminated. Here ANS equals to Y, this is the initialization value. This particular part ANS equals to Y or ANS equals to capital Y, this is the condition, and this particular line ANS equals to input, do you want to run again, this is known as the update condition. This is how a while loop works. It will take a initialization value and it will get inside the loop. After that, at the end, it will ask if you want to run again. Then if you want to run again, if you press Y, then it will keep on running again and again. This is how while loop works. We will see many more examples related to these loops in the upcoming part. I hope that this session was useful. Thank you very much. Hello students, welcome to the chapter on flow of control. This is the part 5 of this particular chapter. I hope you have watched the other parts of this chapter. If not, I have given all the links in the description. You can just refer to the description box for the other parts. So today's topic of discussion will be for loop in Python. See, in the previous part, that is in the part 4, I have already discussed about the basic idea of loop and about the different types of loops, which are while loop and the for loop. But today we are going to specifically deal with for loop along with some related examples. So let's begin with the discussion of for loop. So what is for loop? As already discussed, this is the type of loop that is designed to process the items of a sequence. So in case of for loop, there will be some values within a range or some items within a sequence. Until all the items are processed, the parts within the loop will be executed. Let's go through the syntax. The syntax is as follows. So we have to write for, we have to give a variable in sequence, and then since it is a block, we have to terminate the first line with the help of a colon, and after that, within the same indentation level, we will write the statements which are a part of that particular for loop. Okay, it will be more clear when we go to the related examples after a few minutes. So now, for understanding about the applications of for loop better, we are going to see a few examples. Let us go through these examples. So the programs that we are going to discuss are printing hello world 5 times. Hello world means any message, we'll be printing it 5 times with the help of for loop. Then we'll be printing the squares of numbers up to 5. And then we'll be displaying sum of natural numbers up to n, and finally we are going to print the multiplication table of a number. So let's go and implement these programs one by one. I hope that you are ready with the basic concepts of iterative statements. If not, at first you have to watch part 4 and then you will come back to part 5. Okay, so let's go with our very first program. Now, so what is the use of loop? The use of loop is to simplify repeated operation. See, if you want to print some text 5 times, what you need to do? You need to write that particular text 5 times as follows. So let's say I want to print hi 5 times. So I'll just have to write, if I do not know the concept of loop, what I need to do? I need to write hi how many times? 5 times. But as you can see, this is a repetitive task. Repetitive tasks means same type of operations we are doing again and again. So what can be done in order to simplify this type of tasks? Loops are being discovered. Not discovered, actually these are being developed. Okay, so our first program for the day will be to print hello world 5 times. Let me put it as a comment. So it will be a program to print hello world 5 times using for loop. Okay, so let's follow the syntax. The syntax says that for variable in sequence, variable let's say I, in sequence. For giving a sequence, we can either put it within a list or we can use the range function. About the range function, I have already discussed in part 4. If it is not very clear, you can just refer to part 4. So I'm saying it again, what the range function does, range function will take values within a particular range. Okay, so if I write for I in range, if I write 0, 5, it will take the values 0, 1, 2, 3 and 4. So the range of this particular function is from the lower limit to upper limit minus 1. As you can see, what is the lower limit here? The lower limit is 0. What is the upper limit? Upper limit is 5. Therefore, the range will be from 0 to 4. So what will be the values that the variable I will take? The variable I will take the values 0, 1, 2, 3 and 4. Okay. So after that, since it is a block, so I'll give the colon. As I give the colon, it will leave some space from the left and it will put my cursor over there. So here what I can write, I can just write hello world. Okay, and as I run it, you will find that hello world is being displayed. How many times? Hello world is being displayed 5 times. Now let us try to understand how this particular program is working. Okay, so for that I'll just take you to the whiteboard. So my code is for I in range 0, 5. Remember what this 0, 5, this 0 is the lower limit, this 5 is the upper limit, and it takes values from lower limit to upper limit minus 1. And here what I have written, here I have written print hello world. So at first we will have to find out the values within this range. What are the values within this range? The values within this range will be 0, 1, 2, 3 and 4, because the upper limit is 5, so 5 minus 1 is 4. Now how this particular loop works? The loop works in the following manner. What is the variable here? The variable is I. I will take values one by one from this particular range. So at the first iteration or at the first time of running, I will take the value of how much? I will take the value of 0 and it will come inside the loop. Let's say this is our output screen. What is there inside the loop? Hello world. So what will come in the output screen? Hello world. After that, again, now I will break the previous link and I will take the value of 1 and it will come inside the loop. What is there inside the loop? Hello world. So hello world will be displayed again here. Now again, now I will take the value of 2 and it will come inside the loop. What is there? Hello world is there. So hello world will be displayed again. And similarly, next time 3 will be taken. So again hello world. Next time 4 will be taken. So again hello world will be displayed here. Now as this particular sequence is complete, what will happen? The program will terminate and it will show the following output, this particular highlighted output, where in your output screen. This is how a for loop works. So we are done with the first program, which is printing hello world. How many times? 5 times. Now let us go to the second program, which is printing squares of numbers up to 5. Okay, so we'll have to do to print squares of numbers up to 5. So if I do not know the concept of loop, how to print squares of numbers up to 5, I can just write like this: print 1 into 1, then again print 2 into 2, then again print 3 into 3, then again print 4 into 4, and finally print 5 into 5. So if I run it, I'm getting the squares of number up to 5. Now for that, how many lines have I consumed? I have consumed 5 lines. But this is also a repetitive type of tasks. So instead of doing it in this manner, we can take the help of for loop and do it just in 2 lines. Okay, so let us go for the for loop implementation. So we want to write a Python program. So we want to write a Python program to print squares up to 5. Okay, so let's begin. So if I want to print squares up to 5, what is the starting number? The starting number is 1. So what I'll give for I in range 1 comma, what is, I want to print squares up to 5. So I want the range from 1 to 5. So if I want the range from 1 to 5, here I have to give what? I have to give 6, because the range will be upper limit minus 1. If I give upper limit as 5, then it will take up squares only up to 4. But since I want the correct result, therefore here what I need to do, I have to give the upper limit as 6, so that it takes 1 less than the upper limit. Okay, after that we want to do the squares of the number. Now as you can see here, I will take the value from 1 to 5 one after another. And what we need to do, our task is to take that value of I and square it. So how to write it? I'll write here print I into I. After that, let me just save it and run it. As I run it, what you are getting? You are getting that the squares of number up to 5. If I want the squares of number up to 10, what I'll do here? 1 comma 11 and then run it. I'm getting the squares of number up to 10 here. Okay, so let's see how this particular program is working. Okay, so for that, okay, so the code is for I in range 1 comma 6. Now what will be the possible values in this range? The possible values will be 1, 2, 3, 4 and 5. About the range function, I have discussed in details in the previous part. If you don't know about the range properly, you can go and watch my previous part. The link is given in the description. After that, what I wrote in the code, I wrote print I into I. Now as I have shown in the previous program also, at first I will take the value of 1. So let's say this is the output screen, and then it will come inside the loop. Inside the loop, what we have? Print I into I. What is the current value of I? It is 1. So 1 into 1 is 1. So in the output screen, I will be getting 1. In the next iteration, I will take the value of 2, and then what is there inside the loop? We have I into I. That means 2 into 2, that is 4. So 4 will be displayed in the output screen. Similarly, for the third iteration, 3 into 3, that is 9. For the fourth iteration, 4 into 4, that is 16. And finally, for the fifth iteration, 5 into 5, that is 25. Now, after all the iterations, or after the entire sequence of values are exhausted or completed, it will show you the required output, that is 1, 4, 9, 16 and 25. If you want the squares of number from 1 to 10, then here what you will write? 1 comma 11 and so on. Okay, so in this way we can find out the squares of numbers up to how much? Up to 5. Now let us go to the third program, which is displaying sum of natural numbers up to n. Now what is the meaning of displaying sum of natural numbers up to n? Let us first try to understand that. Now if I say sum of natural numbers up to 1, it is how much? It is 1 only. If I say the sum of natural numbers up to 2, that means 1 plus 2, that means 3. If I say the sum of natural numbers up to 3, the meaning is 1 plus 2 plus 3, that is 6. If I say the sum of natural numbers up to 4, I mean 1 plus 2 plus 3 plus 4, that is 3, 4, 5, 6, 6 plus 4, it is 10. Okay, so this work we have to do using the concept of loop. Okay, here is it a repetitive task? Yes, because after each iteration what we require the next natural number to be added. Here your main intention will be to look for a particular pattern, and based on that pattern you will go through the program. Okay, so let's begin with the program of printing the sum of natural numbers up to n. So let me just write the name of the program to print sum of natural numbers up to n. N means we will ask the user up to what number does the user wants to find the sum of natural numbers. So let's put it as n equals to int input, enter the number till which you want to find the sum, and based on the input given by the user we will return the sum of the numbers. Now before finding out the sum of natural numbers up to n, what is the sum? The sum is 0. So what I'll do, I have taken a variable s and I have initialized it to 0. After that, let us go through the iteration. Now, for I in range 1, because I want to find the sum of natural numbers from 1, comma n plus 1. Why have I given n plus 1? Because whatever number we give here, it will take 1 less. If I want to take up to n, sum up to n, here I have to give 1 more. Only then you will get the correct result. Therefore, I have given here what? N plus 1. After that, what I will do? S. S is the sum. S is the place where the final sum will be there. Then I have given here S equals to S plus I. What it will do, it will carry over the previous sum and it will get added to the new sum again and again. Now how it will work, I'll explain you properly in the whiteboard after a few minutes. After that, finally, once this iteration is complete, the final sum will be stored in this particular variable called S. So what we need to do, we need to display S. So how to display? Sum of natural numbers up to, comma, n, and is how much? It is S. So let's save it and let's run it. Enter the number till which you want to find the sum. If I just say, let's say I'll give here 3. So sum of natural number up to 3 is 6. Verify it. 1 plus 2 plus 3. How much it is? It is how much? It is your 6. Okay, got it? Now let's run it again and check for a different number. Let's say I'll give 5 here. Sum of natural numbers up to 5, it is 15. So if you add 5 plus 4, it is how much? It is 9. 9 plus 3, it is how much? 12. 12 plus 2 is how much? 14. 14 plus 1 is 15. That means our program is working as expected. Now let us see how this program is being done. Let us try to make you understand about this program. Okay, so this is our program. So at first the program will ask you n equals to int input, enter the number till which you want to find the sum. Let's say I give the value of n as 4. Let's say I type 4. Then what will happen? N will take the value of 4. Now what we have initially before this program has running? Initially the value of sum is 0. Therefore I have initialized as to 0. Then what I have for I in range 1 comma n plus 1. What is the value of n we have given? We have given 4 here. It is dynamic. You can give any value in each run. So what we can do, what is the range here? The range is 1 comma n plus 1 means 4 plus 1, that is 5. That means what will be the possible values in the set? The possible values will be 1, 2, 3 and 4. Now while running the program, at first I will take the value of 1 and it will get inside the loop. Inside the loop what we have? S equals to S plus I. That means S equals to S plus I. What is S? S is initially 0. 0 plus I, what is I? I is 1. So S what we have? 1. So as I have got a new value of S, the previous value of S will be erased. Then again this particular loop will run, but this time the value of I will be 2. It will take 2 and it will come inside the loop. Inside the loop what we have? I have S equals to S plus I. What is S now? S is 1. 1 plus what is I is 2. So what I'll get the result as 3. As I get 3, the previous value of s, that is 1, will be erased here. After that, I will take the value of 3 now, and again it will come inside the loop. What we have, s equals to s plus I. What is s? S is 3. 3 plus I is how much? 3. 3 plus 3 is 6. So the previous value of s will be erased, and what is the new value of s? The new value of s is 6. Next, the value of I will be 4. It will take 4 and it will come inside the loop. Here what we have, s equals to s plus I. What is s? S is 6. 6 plus I is how much? I is 4. 6 plus 4 is 10. So the previous value of s will be erased and it will be replaced with the new value of s, which is how much? Which is 10 in this case. Now as you can see, all the values or items within the range has been exhausted. Now what will be done? It will terminate the loop and it will come to the line following the loop. Now here only this line is in this particular indentation level. So only this line will be a part of the for loop. Now it will break this one. It will break the indentation, it will break the loop and it will come to the sixth line. In the sixth line, what is given there? Sum of natural numbers up to. So it will come in the output screen, sum of natural numbers up to n. What is the value of n you gave? You gave the value of n as 4. So sum of natural numbers up to 4 is, after that a colon will be there, is s. What is s? S is your, what is the current value of s? The current value of s is 10. So 10 will be displayed. So in this way, we can find out the sum of natural numbers up to n. Let us just verify this program. If I run this program, it is asking me enter the number till which you want to find the sum. Let's say I'll give as 4. Then I'll get the answer as sum of natural numbers up to 4 is how much? Up to 4 is 10. I've explained it in a whiteboard also. I hope it is very much clear now. Let's go to the last application of today's discussion, which is printing multiplication table of any number. See, this question is also important from examination point of view also, because it is often asked in your examination. So in this program, what we will do, we will ask the user, we will make the program such that it will ask the user for the number for which the multiplication table is to be printed. Let's say the user gives 5, then the entire multiplication table of 5 will be displayed here. Okay, so let's do it. So at first, let us try to find out the pattern in multiplication table. So let's go and find out the pattern now, and after that we will go. So let's say I want to print the multiplication table of 5. Let's see how it is written. 5 into 1 is 5, 5 into 2 is 10, 5 into 3 is 15, 5 into 4 is 20, and so on. Now as you observe it, you will find that the first column, that is 5, it is constant or it is fixed. Okay, so if I take it as n is fixed. Into is to fixed only. This is also fixed. After that, what you are finding? You are finding that these numbers are increasing by how much? They are increasing by 1 each time. And here what we need to do? We need to multiply n, which is 5 in this case, into these numbers 1 by 1. Here you need to, and based on this pattern only, we are going to frame our program. Okay, so let's go and do the programming part of this particular program. So what we will do, we are going to find out the multiplication. We are going to print out the multiplication table. For that, at first we will ask the user for the number for which the user wants to print the multiplication table. So let's take it as n equals to int input, enter the number for which you want the multiplication table. So this line, what it will do, it will ask the user for the number for which the user wants the multiplication table. After that, what we will do, we'll take the help of the for loop. For I in range, this I is just a variable. You can take any variable for that matter. There is no restriction here. Now, in multiplication table, normally we take the values from 1 to 10. Therefore, here what I have to do in range I have to give 1 comma 11. Why? Because it is always one more. After that, what we will do, we'll print here, print. As you look at the board, here you will see that the first column, it is common. What is it? It is n. So here what I'll write, n comma. After that, next thing, what is common here? This particular symbol, that is the cross symbol. It is common because it will come everywhere. And cross. Next, I want the numbers one by one. This particular thing, the third column, it is different. How it is different? Every time we want the numbers incremented by 1. And it will happen how? It will happen with the help of the variable I, because I will take the number serially from 1 to 10. Therefore, what I'll have to give here? I'll have to give here I, comma. Then what I have as common? I have equal to symbol as common. As you can see here, this equal to symbol is also common everywhere. After that, what I require the result. How will I get the result? If I multiply n into I, I'll get the result. Now let me save this particular program and run it. It is asking me enter the number for which you want the multiplication table. Let's say I'll give the number as 5. It is giving me the multiplication table as of 5. Next time, let's say I'll give the number as 12. Enter the number for which you want the multiplication table. So it is giving me the multiplication table of 12. In this manner, you can display the multiplication table of any number. Now let us try to understand the logic behind this particular Python program. Okay, so let us try to understand here. So at first, what I have done, I have taken from the user the number for which the user wants to print the multiplication table. Let's say I'll take the number as 5. So the value of n will be 5. After that, the logic that I have put here is that for I in range 1 comma 11. Why 1 comma 11? Because we want the multiples till 10. Therefore, I have to give the upper limit as 11. So what will be the values within this range? 1, 2, 3, 4 dot 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 up to how much? Up to 10, because the upper limit is 11. So 11 minus 1 is 10. So the highest value of this particular range will be 10. After that, what I wrote print n cross I equals to n multiplied by I here. Now let us try to run this particular program. At first, I will take the value of 1. So let's take this as the output screen. So what will come in the output screen? N. What is n? N is 5. Then what I have cross I. What is the first value of I being taken here? It is 1. Then what I have the equal to symbol, equal to n into I. What is n? N is 5. 5 into I is what? 1. It is how much? It is 5. So 5 will be displayed as the result. Next, the value of I that will be taken is 2. So what will be displayed? I have used the print statement, therefore it will be directly displayed. N. What is n? N is your 5 here. 5 cross I. What is I now? I is 2, equal to symbol. N cross I. What is n? N is fixed, that is 5 into I is how much? I is 2 now. 2 equals to 10. Similarly, next time I will have the value of 3 and it will come inside the loop. What I have there? I have print n. What is n? N is 5. So 5. Then I have cross. So cross will be displayed I. What is I now? I is 3 now. Equals to. Then I have equals to n into I. What is n? N is 5 into what is I? I is 3 now. 5 3s are how much? 15. So 15 will be displayed here. And so on. In the same manner, the multiplication table will be displayed up to the multiples of 10. Okay. So these were some of the applications of for loop. we have discussed about printing a message 5 times, printing the squares of numbers up to 5, displaying sum of natural numbers up to n, and printing the multiplication table of any number. I hope with this the for loop is clear. Thank you very much. I'll see you again in the next session. Hello students, welcome to the chapter on flow of control. This is the part 6 of this particular chapter. I hope that you have understood and watched the previous parts of this particular chapter. If not, I've given all the links in the description. You can of course click on the links in the description and view the other parts of this particular chapter. So today's topic of discussion is while loop in Python. So at first I'll give you a brief idea about while loop, and then we'll be going to the practical examples related to while loop in Python. So let's go towards the concepts of while loop. So what is while loop? It is a conditional loop that repeats the instructions within while loop as long as a condition remains true. Now, as we have already seen in the previous parts, that there are two types of loops. One is the counting loop, which is the for loop, and next is the conditional loop, which is the while loop. So while loop, what is the while loop? While loop, it is a conditional loop. That means depending upon a condition, the instructions within the while loop will be executed. After a while loop is executed for an iteration, the condition is tested again. So at first the condition will be tested. If the condition is true, then the instructions within that condition or within the while loop will be executed, and at the end of the while loop, after executing all the statements, the condition is tested again. If the condition is still true, then again the while loop will continue to run. There will be a time when the loop will evaluate to false. As the while loop evaluates to false, at that moment the condition will become false, and as the condition becomes false, the while loop will be terminated. There is a syntax of while loop, and this is the syntax of while loop. At first there will be a initialization value, and after that there will be a condition, and based on the condition the statements within the while loop will be executed. Towards the end you can find something in the syntax which is known as the update condition. What is update condition? See, after a condition becomes true, the statements within the while loop will be executed, and at the end of execution the value of the condition will be updated, and after updating it will be checked whether the condition is true again or not. Don't worry if it is not very clear now, we'll check it out with the help of some practical examples. So we'll see some related programs related to the while loop. Now while loop is basically used for running a program multiple times. We'll see how while loop can be used for running a program multiple times, and then we'll see the factorial of a number using while loop, and finally we'll wind up our discussion with a program on Fibonacci series. So let's try to see how while loop can be used for running a program multiple times. Let's see, say we want to write a program to add two numbers. So let's quickly write a program to add two numbers. I'll write a basic program like x equals to int input, enter the first number. Then what I can do, I can just copy this particular line and then I'll paste it here. I can give y equals to int input, enter the second number. Then what I can do, I can write z equals to x plus y. So the value will be stored, the answer will be stored in z. So finally we can display z like this, like sum is comma z. Okay. Now if I now I'll save this program. Now I'll run this program. Enter the first number, let's say I'll give 8, enter the second number, let's say I'll give 2. So I'll get that the sum is how much? The sum is 10. If I have to run again, I have to press on the run key again, and then again it will ask me enter the first number 3, enter the second number, let's say I'll give 2 now. So it will again give the sum as 5. Now if I want to run it again I have to press on the run button. But there is a better approach to do this instead of pressing the run button again and again for multiple times. So how can it be done? It can be done as follows. So before running the program, what we can do, we can take any variable. Let's say the variable name is ANS. ANS stands for answer. ans equals to, let's say we have initialized it to y. This is the first part of the syntax of while loop. Now what did the first part of the while loop syntax says? The first part says that we'll have a initialization value. What is the initialization value in this case? The initialization value in this case is y. Okay, after that what we will write? While ans equals to small y or ans equals to capital Y. What is the, then see the next line of the syntax. The next line says that after while we have to give a condition. What is the condition here? ans equals to y or ans equals to capital Y. This is the condition. That means the statements within the while loop, that means these statements will be executed till the condition, that is ans becomes equals to y. So these are the statements like statement 1, statement 2, statement 3 up to statement n, and at the end we will update the condition. How to update the condition? We will ask the user if the user wants to run this program again or not. So how can we do that? We can take the same variable which is ans equals to input. Do you want to run the program again? We can give instruction like this, and then we can give like y/n. Okay, we'll give a instruction in this manner, and then let us save this program. Now I'll run this program. Okay, what it is asking me? It is asking me enter the first number. Let's say I'll give the first number as 5. It is asking me to enter the second number. Let's say I'll give the second number as 2, and it is giving me that the sum is 7. After that, it is asking me, do you want to run the program again? Yes or no? If I press Y, what will happen? The value of ans will become y. So again this loop will be tested, and it will find that the loop is true now also, and again it will give me a chance to enter the first number again. So again if I enter the first number as 9 and second number as 2, I'll get the sum as 11. It is asking me, do you want to run the program again? Let's say I'll put n here. So now the condition will become false. Now how this program has been executed? At first ans has been given the value of small y, and after that it has been tested whether ans equals to small y or not. Yes, ans equals to small y. So since it is true, the statements are executed, and at the end what I have given, I have taken the same variable ans and I have asked the user, do you want to run the program again? Now if the user presses small y or capital Y, no matter whatever the user presses, the condition will be tested again. Now if the user press Y, then the condition will become true again, and this set of statements will be executed. But if the user press N, then this condition will become false, because ans, if I press N is not equals to small y or capital Y, therefore the loop will be executed. Loop will be terminated. So for running a program multiple times, you can use this particular technique. So this is the first application of while loop. It is a very useful technique for running a program multiple times. Now let's go and try to understand the second related program of while loop, which is finding out the factorial of a number. So before implementing the program, let me try to make you understand the meaning of the word factorial. Okay, so if I write factorial 5, this is the symbol for factorial. It can also be denoted as follows. Okay, so let's take the first one only. So this is known as factorial 5. Factorial 5 means 5 into 4 into 3 into 2 into 1. That means 5 4s are 20, 3 2s are 6, 20 into 6 is 120. Similarly, if I have to find factorial 4 means 4 into 3 into 2 into 1. That is 3 2s are 6, 6 4s are 24, and so on. Another thing to note that factorial 0 is 1. Okay, so here as you can find, the next number is found by subtracting 1 as compared to the previous number. Okay, so here we'll use the concept of while loop for finding out the factorial of a number. So without any further delay, let us try to find out the factorial of a number. So what I'll do, I'll overwrite over this program only. Let me write the name of the program, which is, let's say, write, or I'll directly write factorial using while loop. Okay, so at first I'll ask the user what number the user wants to find a factorial for. So let me write n equals to int input, enter a number to find a factorial. So we'll receive, with this line, we'll receive the number for which the user wants to find a factorial. Okay, after that, what I'll do, see, factorial 0 is what? Factorial 0 is 1, factorial 1 is also 1. That means what is the minimum factorial? The minimum factorial is 1. Therefore, let me take a variable, let's say f, and I'll initialize f to 1. After that, let's take another variable, let's take I also, I'll initialize it to 1. After that, what I'll do while I less than equals to n, you'll get to know when we'll complete the program why I have given this particular condition. So here what I'll give, f equals to f into I. Okay, then what I'll give, a equals not a, I equals to I plus 1. This is the update condition. So what is it? This is the update condition. I've used a single line comment to make you understand this, and here what I have done, I have multiplied it, okay, after updation. Now as I complete, I can display the factorial of the number, like factorial of, let's say the number is denoted by the variable n is, I can, now where will the final result be stored? The final result will be stored in the variable f. So what I'll do, I'll just write f here, and then let me run it. Enter a number to find the factorial. Let me give 4 here. So I'm getting factorial of 4 is how much? It is 24. Yes, it is 24. If I run it again, I'll give the, let's say I'll give the factorial as 5. I'm getting factorial of 5 is 120. Hence it is correct. If I give the number as 0, I'm getting factorial of 0 is 1. So this is also correct. Now let me make you understand how this particular program is running. Now let's pay attention to the first line, which says n equals to int input, enter a number to find the factorial. That means the program is asking the user to enter the number for which the user wants to find the factorial. So let's say I want to find the factorial of 4. So I'll give the value of n as 4. After that, let's look at line number 3. F is how much? F is 1 and I is 1. So let me just write it here. F is 1 and I is 1 initially. After that, what I have given here while I less than equals to n. Okay. So what is the value of I in this case? The value of I in this case is 1. 1 less than equals to 4. Yes, 1 is less than 4, so the condition is true, so it will come inside the loop. Inside the loop, what I have given? F equals to f into I. So what have I given here? F equals to f into I. What is f? F is your 1 initially into I. What is I? I is also 1 initially. So what is the final value of f now? The final value of f is 1 during the first iteration. Now let's look at the next line. The next line says that I equals to I plus 1. So what follows this line? I equals to I plus 1. What is I? I is 1 initially, so 1 plus 1 will get I as 2. Now since I have got I as 2, the previous value of I will be replaced by 2 and the previous value of f will also be erased. So what is the current value of f? The current value of f is 1 and the current value of I is how much? 2. Now after this, again the condition will be tested. Why? Because these two lines are a part of the while loop. Now what will be the value of I? The value of I is 2. So this condition will be tested as follows. So 2 less than equals to n. N is how much? N is 4. So again it will go inside the loop. So what will happen over there? It will happen f equals to f into I. So f equals to f into I. What is the current value of f? Current value of f is 1 into I. What is the current value of I? The current value of I is 2. So the factorial currently is how much? It is 2. Now what we have? I equals to I plus 1. What is the current value of I? It is 2. 2 plus 1 is how much? 2 plus 1 is 3. So the previous two values of I and f respectively will be erased with the new values 2 and 3 respectively. Now again this particular condition will be checked. Now what the condition says I less than equals to n. What is I? I is 3. 3 less than equals to 4. Now is 3 less than equals to 4? Yes, it is correct. 3 is less than 4. So again f equals to f into I will be taken up. Now what is f? F is 2. 2 into I means how much? It is 3. So f is how much? F is 6 now. I equals to I plus 1. This line will be followed. What is I? I is 3 currently. 3 plus 1 is how much? 4. So the previous values of f, that is 2 and 3, will be erased with the new values 6 and 4 respectively. Now again the condition will be checked, that is 4 less than equals to 4. Is 4 less than 4? No, 4 is not less than 4. Is 4 equals to 4? Yes, 4 is equals to 4. That means the condition is true. So it will come inside the loop again. What is there inside the loop? At first f equals to f into I is there inside the loop. So what we'll get here? F equals to f into I. What is f? F is 6. 6 into I is 4. 6 into 4 is how much? 24. And then I equals to I plus 1. This line will be executed. What is I? I is 4. 4 plus 1 is 5. So now f is how much? F is 24. After that again the condition will be checked. Now again what is the condition? The condition is I less than equals to n. Now what is the current value of I? The current value of I is 5. 5 less than equals to n. What is the value of n? N is 4. Is 5 less than 4? No. Is 5 equals to 4? No. That means it is false. Now since the loop has become false now, so what will happen? Since the loop has become false now, therefore the loop will be terminated. Okay, and while the loop is being terminated, what is the value stored at the variable f? The value stored at the variable f is your 24. So what is the last line of the program? The last line of the program is print factorial of n is f. So what will be displayed in your output screen? It will be displayed as follows. Factorial of n. What was the value of n? 4 is f. What was the last value of f? The last value of f is 24 before termination. So 24 will be displayed as the answer. You can check and trace it manually using any value of n. So I hope that the factorial of a number is clear to you. Now let's go to the last program of today's discussion, which is the Fibonacci series. Now before going to the actual discussion of Fibonacci series, I would like to give you a brief idea about what a Fibonacci series is. A Fibonacci series, so we are going to discuss about what? We are going to discuss about Fibonacci series. Fibonacci series is a series of number which is in the form 0, 1, 1. These are the three values of the, okay, if we just take 0 and 1, these are the first two values of the series, and the next value is found out by adding the previous two values. So what will be the next value here? The next value will be 0 plus 1, that is 1. What will be the next value? Next value is found out by adding the previous two values. That means 1 and 1 we need to add. 1 plus 1 is 2. What is the next value? Next value will be taken up by adding 2 and 1. 2 plus 1 is 3. What is the next value? 3 plus 2, it is how much? 5. Next value will be 5 plus 3 is 8, and so on. So in this way the Fibonacci series will be formed. Now our aim will be to display the Fibonacci series up to n terms. What is the meaning of this? The meaning is that if the user presses, let's say 4, that means the value of n is 4. So these 4 terms are to be displayed. If the user presses 2, then only the first 2 terms, that is 0 and 1, needs to be displayed, and so on. Okay, so we'll write a program in Python to display Fibonacci series up to how many terms? Up to n terms. So without any delay, let us try to implement Fibonacci series. Fibonacci series. Here also we'll be using the concept of while loop. So at first we'll ask the user up to what term the user wants to display the Fibonacci series. We need to display each and every term up to that particular term. So we'll give the message as follows: enter the number of terms till which you want to display the Fibonacci series. Okay, we'll take this from the user. Let's give a /n here. After that, what we'll do, we'll put the initial value. What is the initial value of the Fibonacci series? It is the 0. What is the second value of the Fibonacci series? This is 1. These two values should definitely be initialized in the program because these two values are fixed. After that, let's take another variable. Let's take the variable as count as 0 because we have not yet started the program. After that, if n is less than equals to 0. Now see, user may give the input in negative, but the input cannot be in negative because at least there should be one term. So if the user gives a negative input, we can filter it out by this condition, like if n is less than equals to 0 as invalid input. Okay, after that, if the user gives the input as 1, so if n equals to 1, then also no logic is required. We can directly display it like this: Fibonacci series up to n term is, so if the user presses 1, then the Fibonacci series will consist only of the value of n1. So we can directly display n1 here. Now, okay, not else, this will be your elif. Now the final actual logic will come within the else part. I have already discussed about if, elif, else in the selection statements part. If it is not very clear, you can just revisit the selection statements. Now in the next line, I'll just display the message like Fibonacci series up to, let's say, n terms. Okay, we'll just display it like this: Fibonacci series up to n terms, and then we'll apply the while loop here. While count less than n, we can give here print n1. Don't worry if it's not very clear now, I'll explain each and every line of this particular program. Nth equals to n1 plus n2, and then n1 equals to n2. Finally, nth equals to n1 plus n2, and then we have to give n2. It has to be initialized to, it has to be supplied to nth, and then finally we have to update the counter. Count equals to count plus 1. This is the update condition, and as it is complete, we can just give ... at the end. Okay, so at first let us run this program. So it is asking me enter the number of terms till which you want to display the Fibonacci series. Let me give the number as 5. So the first 5 terms of the Fibonacci series is being displayed here. Okay, after that, if I just run it again, enter the number of terms till which you want to display the Fibonacci series. If I give 1, so Fibonacci series up to 1 term, it is 0. Let's give an invalid input. Let's give the input as -9. So it is giving me the invalid input. Okay, Now let us try to understand this particular program by taking input as 4. Okay. So let us try to understand this particular program. So at first, what will happen? The program will ask the user for the number of terms till which the user wants to display the Fibonacci series. Okay, so number of terms will be taken by the user and it will be displayed by the variable n. Let's say I'll want to display up to 5 terms. So I'll give, the value of n will be 5. After that, n1 is initialized to 0, n2 is initialized to 1, count is initialized to 0. So n1 is 0, n2 is your 1 and count is 0 initially. Okay. After that, here if n is less than 0, that means if the user gives a negative value, then we'll get invalid input. If n is 1, then Fibonacci series up to 1 term is n1, it will be displayed. After that, the main part will come from the 11th line, that is Fibonacci series up to n terms. So if I give the value of n as 5, so it will be displayed Fibonacci series up to 5 terms. After that, while count less than n, okay, so what is given here? While count less than n. What is the value of count? Count is 0, 0 less than n. What is n? N is 5. Is it true or false? Yes, it is true. Therefore, it will come inside the loop. Inside the loop, what we have? Print n1, and then what we have? N equals to comma. That means comma will be displayed after displaying the value of n1. So let's assume this to be the output screen. So n1 will be displayed. What is n1 here? 0, 0, comma. Okay. After that, what happens? Nth equals to n1 plus n2. So nth equals to n1 plus n2. So what is n1? n1 is 0, n2 is 1. So nth will become what? Nth will become 1. After that, what the next line says? The next line says that n1 equals to n2. So next line says n1 equals to n2. So what is present at n2? n2 is 1. So n2 will come to n1. So previous value of n1, that is 0, will be erased. After that, what we have? We have n2 equals to nth. We have n2 equals to nth. So what is the value of nth? The value of nth is 1 now. So 1 will be assigned to the variable n2. Okay. After that, what we have? The final line we have as count equals to count plus 1. So c equals to c plus 1. I have written in the short form. What is the value of count now? It is 0. 0 plus 1. It is how much? 1. So we'll erase the previous values. So now again the condition will be checked, that is c is less than n, that is 1 is less than n, 1 is less than 5. Is it true or false? Yes, it is true. So it will come to the next line. In the next line, what is given? Print n1. So what is the value of n1 now? The value of n1 now is 1. So since it is the output screen, 1 and comma will be coming here. After that, what we have? Nth equals to n1 plus n2. So nth equals to n1 plus n2. What is n1? n1 is 1. What is n2? n2 is 1. So 1 plus 1 is 2. The value of nth is 2 now. So the previous value of nth, that is 1, will be erased. After that, what we have? n1 equals to n2. So n1 equals to n2. What was the value of n2? n2 is 1. So n1 will be 1 now. Then what we have? n2 equals to nth. What is the value of nth now? Nth is 2. So n2 will also be 2 now. After that, what we have? C equals to c plus 1. What is c? C was 1 initially. 1 plus 1, it is 2. So the previous value of c and n2 and n1 will be erased because we have got some new set of values now. After that, again the condition will be checked, that is c less than n. What is c? C is 2 now. 2 less than n means 5. Is it true or false? Yes, it is true. So n1 will be displayed because we have given print n1. What was the value of n1? In the previous step it was 1. So 1 and comma will be there. After that, what is the next line? The next line says that nth equals to n1 plus n2. So nth equals to n1 plus n2. N1 is how much? It is 1. 1 plus 2, it is how much? It is 3. So nth is 3. After that, what will be the next line? Next line will be n1 equals to n2. N1 equals to n2. What is n2? N2 is 2. So n1 will become 2. And n2 equals to what? N2 equals to nth. What was the value of nth in the previous step? It was, in this step it is 3. So n2 will be 3. After that, what we have? We have n2 equals to nth. Yeah. After that, we will have the counter c equals to c plus 1. C was 2. 2 plus 1 is 3. After that, again the condition will be checked. That is, c is less than n. What is c? 3. 3 is less than 5. Is it true or false? Yes, it is true. So it will come inside the loop and it will display n1. What is n1 now? n1 is 2. So 2 will be displayed in the output screen. After that, what is there? nth. Nth equals to what? Nth equals to n1 plus n2. So what is n1 now? n1 is now 2. What is n2? n2 is 3. So 2 plus 3, that is 5, will be stored in nth. After that, what we have? After that, we have n1 equals to n2. n1 equals to n2. What is n2 now? n2 is 3. So n1 will be 3 now. Then what we have? n2 equals to nth. n2 equals to nth. What is nth now? nth is 5 now. After that, what we have? We'll update the counter. Counter means c equals to c plus 1. C plus 1 means how much now? It is 4 now, because previously it was 3. 3 plus 1 is 4. So again the condition will be checked. So what is the condition now? While the condition is while count less than n. Count was how much? Count was 4. 4 less than n. What was n in the previous step? The n is your 5. 4 is less than 5. Yes, it is true. So n1 will be printed. What was n1 in the previous step? N1 was 3 in the previous step. So since this is the output screen, 3 and comma will be printed here. Okay. After that, what we have? We have the next line, which is nth equals to n1 plus n2. So nth equals to n1 plus n2. What was n1 in the previous step? It was 3, n2 is 5. So 3 plus 5, that is 8. After that, what is the next line? Next line is n1 equals to n2. So what was n2 in the previous step? It was 5. So n1 will be equals to 5. What was the next line? The next line is n2 equals to nth. What was nth? Nth is 8. So n2 is how much? n2 is 8. After that, we have c equals to c plus 1. What is c? C is 4. 4 plus 1 is how much? It is 5 now. Okay. After that, the condition will be checked again. So now what is the condition? C is less than n. So c is how much? 5. 5 is less than n. N is how much? 5. Is 5 less than 5? False. Since it is false, it will come out of the loop. Now at the end of the loop, what we have? We have dot dot dot. So what will be displayed in the output screen after displaying the 5 values? Dot 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 will be displayed. Therefore, if I run this program and give the value of n as 5, I am getting the answer as 0, 1, 1, 2, 3. Now as I have computed manually, here also I have got the answer as what? I have got the answer as 0, 1, 1, 2, 3. Now in this way, a while loop is executed. So we have a initialization value. After that, there will be a condition. As long as the condition becomes true, the loop will be executed, and at the end, the condition will be updated, and again the condition will be checked, and it will go on. This process will go on until the condition becomes false. Okay, that's all about while loop. I hope that this session was useful. Thank you very much. Hello students, welcome to the chapter on flow of control. This is the part 7 of this particular chapter. I hope that you have watched the other parts of this chapter. If not, I've given all the links in the description. You can of course go and watch from the description box. So today's topic of discussion is jump statements in Python. So let us quickly go to the concept of jump statements. So what do we mean by jump statements? Before going to the practical aspect of jump statements, we need to understand what jump statements are. So these statements can be used within loops to jump out of loop iterations. So within loop, some certain statements can be used which can prematurely terminate a loop or skip certain iterations of the loop. So if you want to prematurely jump out of the loop or skip certain iterations of the loop, then you can use these categories of statements known as jump statements. As we go with the definition, these statements can be used within the loops. That means break statement, jump statements, this will be used within the loop, and these will be used to jump out of the loop iterations. Jump statements, these are categorized into two categories. First is break statement and the second is continue statement. These two statements are very important and it will be implemented in lots and lots of code from now on. So let's quickly go and try to understand the break statement. So what is a break statement? This statement is used in Python to skip over a part of the code. Now let's say you are running certain statements within a particular loop. Now, after a series of statements are executed based on a condition, you might want to terminate the loop prematurely. Prematurely means before all the iterations are complete. If you want to terminate the loop based on some conditions, then you can use the break statement. So, mainly it will do the work of the skipping part of the loop. It skips the rest of the iterations of the loop and jumps over to the statements following the loop. So whenever you see a break statement is there within a loop, and when the break statement is reached, at that time the loop will be terminated and the control will be skipped to the statement after the loop. And execution resumes at the statement immediately following the body of the terminated statement. And after the loop is terminated, the program will not terminate, only the loop will terminate and the control will again go into the statement following the loop. That means after the loop, if there are certain statements, those statements will be executed as the loop is terminated prematurely because of the break statement. Let's see some of the formats of break statement. So here I have given a while loop. Within the while loop, as you can see within blue color, I have if condition. Within the condition, I have a press statement called break. Now whenever the break statement is reached within the loop, what will happen? The loop will be terminated and the statement and the control will go to statement number 4. As you can see, statement 4 is a statement which is outside the while loop. Okay, so as soon as the break statement is encountered, the loop will be terminated. Don't worry if it's not very clear, I'll explain it very soon in this part only with the help of practical Python code. Similarly, it can also be used along with for loop. Here also you can see within the loop, you can see a break statement here. Now, whenever the break is encountered, the loop will be terminated and the control will go to the statement after the loop. Which is the statement after the loop? Statement 4 is the statement after the loop and the loop will be terminated. Okay, so let us go and try to understand the break statement with the help of a practical example. Okay, so this will be a program to illustrate. So the name of the program can be illustration of break statement. Okay, so let's just write a print statement here which says, let's say, output with break. Okay, now let's put a loop here like for I in range 1 comma 11. Now 1 comma 11 means what will be the possible values which I will take. The possible values will be from 1 to 10. I have already explained you about the range function. If it's not clear, then you can looked to in the previous parts of this chapter. Now within this, let me put a condition. If I modulo divide 3 equals to 0, then let's put a break here. That means this is called as a remainder division. If the remainder is 0, then the program will be terminated prematurely. And if it is not 0, then let us put a else code. I'll trace the program line by line, don't worry. So print I, that means the value of the range will be printed here. So if I run it, I'm getting the output as output with break 1 and 2. Now let us analyze why we have got this particular output. Okay, I'll explain it to you in a board. So what was the first line? So let's say this is your output screen. So what is the first line of the code? First line is output with break. So what will come in the output screen? In the output screen, it will come as output with break. After that, what is the next line of the code? Next line is for I in range 1, 11. So for I in range 1, 11. Now what will be the possible values for this range? It will be 1, 2, 3, 4 dot dot up to how much? Up to 10. Because within the range function, the range is from lower limit to upper limit minus 1. Here the upper limit is 11. So the range will be from 1 to 10. Now within that we have a condition. Look at the condition. What we have? If I modulo divide 3 equals to 0. Now what we have here, let me write the code. It's a small code. If I modulo divide 3 equals to 0, we have the break statement here. Else we will print the value of I. Now at first I will take the value of 1, okay, and then this particular condition will be tested. I modulo divide 3 equals to 0. What is the value of I now? The value of I is 1. 1 modulo divide 3 equals to 0. Now if I divide 1 by 3, is the remainder 0? This is called as the remainder division. I have already explained in the previous parts. Now here the remainder is not 0. That means the condition is false. Since the condition is false, the control will come to the else part. So what is there? Print I. What is the value of I now? It is 1. So 1 will be printed in the output screen. Okay. Similarly, now the next iteration of loop will run. Now I will take the value of 2. Now what will happen here? Now the condition will again be checked here. If I modulo divide 3 equals to 0, what is I now? I is 2. So 2 modulo divide 3 equals to 0. Is the condition true or false? Again the condition is false, because if I divide 2 by 3, the remainder is not 0. So since the condition is false, even now again the control will come to the else part. What is there? Here we have print I. What is the value of I now? The value of I is 2. So 2 will be printed in the output screen. Okay. After that, what will be the next value of I? The next value of I will be 3. Here again the condition will be checked, which is 3 modulo divide 3 equals to 0. So if I divide 3 by 3, will the remainder be 0? Yes, the remainder will be 0. Now pay attention at this point. Now since the remainder is 0, the condition has become true now. Now since the condition has become true now, the control will come at this line. What is written here? Break. Now as we already know, whenever the break statement is there, the control will come to the statement after the loop. That means the loop will automatically be terminated. That means rest of the iterations like 4, 5, 6, 7, 8, 9 and 10, these will not be executed. That means the loop has been terminated prematurely. Why it has happened? Because of this particular statement called as the break statement. So remember, whenever a break statement is encountered, the loop will be terminated and the control will come to the statement after the loop. Okay, so therefore we have got the output as output with break 1 and 2 here. I hope that break statement is clear. Now let us go to the next statement, which is the continue statement. So continue statement, this statement is used to skip over a part of code. Now if you want to skip a part of code only temporarily, means only for the current iteration, then we will use a statement known as the continue statement. Whenever a continue statement is encountered, it skips the rest of the current loop statement and causes the next iteration of the loop to take place. Now, unlike break, whenever continue is encountered, the loop will not be terminated. Rather, only that iteration will be terminated. Only that iteration will be skipped. Okay, I'll explain you with the help of an example. So let's say this is your for loop. Now within the condition we have the continue statement highlighted in blue. Now whenever continue statement is executed, then it will go to the next iteration of the loop. So it will continue with the next iteration. The loop will not be terminated. Similarly, for while loop also, whenever continue statement is there, it will continue with the next iteration. So basically, if I have to sum it up in one line, I'll say that continue statement will skip only the current iteration of the loop and not the entire loop will be terminated. Entire loop will be terminated in case of break, but in case of continue statement, only the current iteration of the loop will be terminated. Now let us see it with the help of a practical example. So I'll use the same Python code in this particular program only. So here I can just change the name of the program to illustration of break and continue. This can also be said as the difference between a program to illustrate the difference between break and continue statement. So let me write those statements. So let me write here output with continue. Okay, I'll use the same code here. Here let's give the same code for I in range 1, 11. Then let me give the condition if I modulo divide 3 equals to 0, and let me give continue here, and here let me give a else statement and print the value of I. Now let me save it and run this program. As I run this program, what am I getting? Output with break 1, 2, output is with continue 1, 2, 4, 5, 7, 8 and 10. Now let's see why this is happening here. Okay, so let me just see the continue part. So let's say this is our output screen. So what is the first line? First line is I am showing only the continue part, output with continue. After that, what I have there for I in range 1, 11, if I modulo divide 3 equals to 0, here we have the continue statement, and else we print the value of I. Now let us trace this program. Now what will be the value of I? It is as the previous one. It will be from 1 to 10. Okay, so at first I will take the value of 1 and it will come inside the loop. Here if I modulo divide 3 equals to 0, that means 1 modulo divide 3 equals to 0. Now here the condition is false, so it will come to the else statement. Here what we have, print I, what is the current value of I? It is 1, so I'll get 1 in the output screen. After that again I will now take the value as 2, so 2 modulo divide 3 equals to 0. Now also the condition is false, so it will go to the else part. What is there? Print I, what is the value of I? It is 2, so 2 will be displayed in the output screen. Now next, what will be the value of I now? If I modulo divide 3 equals to 0, next the value of I will be 3 here. So if 3 modulo divide 3 equals to 0, now the condition is true because if I divide 3 by 3, the remainder will be 0. So the condition is true. Since the condition is true, it will come inside this if block. Now what is written there? Continue is written there. So the current iteration will be skipped and the control will again go and continue with the next iteration. So iteration number 3 will be skipped and iteration number 4 will be executed and this condition will be checked. What is here? If I modulo divide 3 equals to 0, 4 modulo divide 3 equals to 0. Here it is not completely divisible, therefore the remainder is not 0, so the condition is false. Since the condition is false, the control will come to the else part. Here what we have? Here we have print I. What is the value of I? The value of I is 4, so 4 will be displayed in the output screen. After that, what will be the next value of I? It will be 5. 5 modulo divide 3 equals to 0. I am checking this condition. The condition is false. So again control will come to the else part. Here what is there? Print I. What was the value of I? It is 5. So 5 will be displayed in the output screen. Then again the next value of I will be taken, which is 5. So if 5 modulo divide, now the next value of I is how much now? 6. So if 6 modulo divide 3 equals to 0. Yes, if I divide 6 by 3, I will get the remainder as 0. Therefore, the condition will become true. Since the condition will become true here, the control will go to the if block. What is there? Continue block, continue is there. So that particular iteration will be skipped. So 6 will not come in the output screen here. So again next iteration will be executed. Now what we have? The value of I is 7. 7 modulo divide 3 equals to 0. No, the condition is false. So it will go to the else part. What is there within the else part? Print I. What is the value of I? It is 7. So 7 will be printed. Similarly, after that 8 will be printed. 9 will not be printed because remainder will be your 0 in case of 9, and then 10 will be printed here. Okay. So which are skipped? Numbers 3 is skipped, number 6 is skipped, and number 9 is skipped here. Why? Because at those moments, this condition I modulo divide 3 equals to 0, these conditions became true. So remember, in case of continue statement, only the current iteration of the loop will be terminated and the entire loop is not terminated. But in case of break statement, the entire loop is terminated. Okay, I hope the difference is clear. Now let us go to the last concept of today's part, which is the loop else statement. So the loop else statement is executed in Python in case the loop terminates normally, not when the loop is terminating because of a break statement. So within a loop, we may have break statement. Now if the loop is being terminated because of the break statement, the loop else statement will not be executed. But if the loop executes normally, then the loop else statement will be executed. Let us take this as the syntax. Here we have a statement called as a loop else statement. Remember, loop else statement is different from if else statement. Loop else statement has the same indentation level as the for. As you can see, for and the else, both of these two is being written from the boundary of the Python interpreter. Okay, so take care of this indentation. Now, if the loop is being terminated normally, as you can see here, normal termination of the loop, then the else statement will be executed. Got it? But you may have break statement within for loop. If you have break statement within for loop, that means if termination is due to break, then the else loop else statement will not be executed. Got it? Again, if we try to understand the same concept with respect to the while loop, here also, if the loop is terminated normally, then the else statement will be executed. But within while, if I have break and the loop terminates because of the break statement, then the else part will not be executed. Okay, so let's try to understand it with the help of an example. Now what we will do, we'll try to write a program to check whether a number is prime or not, and in doing so we'll be using the loop else statement. So let me write the question as a comment here. So write a program in Python to check whether a number is prime or not. Okay. Now all of you know what is the meaning of prime number. Prime number is such a number which has only two factors. Okay. So what is a prime number? So prime number, it is such a number which has only two factors. What are the factors of prime number? The number itself and 1. For example, if I take 7, there are only two factors of 7, which is 1 and 7. So what is 7? 7 is a prime number. But if I take 9 here, 9 has the factors 1 and 9, but along with that it has another factor called 3. So if there are more than two factors, that means if you have at least one factor which is other than the number itself and 1, then we can say that it is not a prime number. Understood? That's the simple thing regarding prime number. Also you should know that the smallest prime number is 2. What is 2? 2 is the smallest prime number. Okay. Next, so let us now implement this program. So at first we need to ask the user for the number for checking for prime. So we'll accept the number from the user. So we can just write here int input, like enter a number to check for prime. Okay. So the user will enter a number to check for prime. Now let us do a filtering here. Let's say the now if number greater than 1. So our logic will only run if the number is greater than 1. Why we have done this filtering? Because 1 is not a prime number. So here let us now put it within a loop for I in range 2, n. Why we have started the range from 2? Because 2 is the smallest prime number. From 2 we have to check till n. Till n means we have to check for one number, we have to traverse the loop for one less time than the actual number. That means if the number entered is 7, ideally the loop will run for 2, 3, 4, 5 and 6. Okay, because we need not check the last number. After that, what we need to do, we need to divide the number which is n. So therefore I am using the if statement. If n modulo divide I means 2 equals to 0. That means we will go on dividing the number with numbers starting from 2 to n minus 1. So if the remainder is 0, what we can say? We can say that n is not a prime number, because upon dividing by some number except 1 and the number itself, if we are getting the remainder 0, that means there is at least one factor except 1 and itself. Now if I get a prime number, then I need not check for the other factors, because if there is at least one factor which is other than 1 and the number itself, we can immediately declare that it is a prime number and we can come out of the loop. Therefore we have given the break statement here. Now here let me use the loop else statement. Now if the program terminates normally, when will the program terminate normally? Try to understand here. The program will terminate normally when this condition never becomes true. When will this condition never become true? In case of prime numbers only. That means the loop will terminate normally in case of the prime numbers. Therefore, here within else what we can write? We can write n means the number is a prime number. Now here we have started a if, so we have to end it with a else. We can write here if the number is not greater than 1, we can immediately declare that the number is not a prime number. Okay, now let me run this program and check it out. Enter a number to check for prime. If I enter 7, it is giving me the correct answer, that is 7 is a prime number. If I run the program again, if I just give here 18, yes, it is giving me the correct answer, that is 18 is not a prime number. If I give here 1, then also it is giving me the correct answer that 1 is not a prime number. Okay, now let us try to understand the running or execution of this particular program. Okay, so let me take a number. So what does the first line says? The first line asks the user for a number. N equals to int input, enter a number to check for prime. So let's say this is our output screen. So what will come in the first line? Enter a number to check for prime. Okay, so let's say you have entered the number as 3. So number is held by the variable n. So in n what will be stored? 3 will be stored. After that what we have, if n greater than 1, n greater than 1, 3 is greater than 1, is it true or false? Yes, it is true. So it will come inside the if statement. Within that what we have, for I in range 2 comma n. So for I in range 2 comma n. So what is n? N is your 3. So let me take a larger number. Let me take the number as 5. So 5 is greater than 1. So for taking a greater range, so it will be for I in range 2 comma n, that means 2 comma 5. 5 will come in place of n. So what will be the possible values? 2, 3 and 4. Okay. So at first I will take the value of as 2 and come inside the loop. Now what is there inside the loop? If n modulo divide I equals to 0. So if n modulo divide I equals to 0. What is n here? N is 2. Now 2 modulo divide I. So what is n? Sorry. N is how much? N is your 5. So 5 modulo divide I. What is I? I is 2 equals to 0. So if I divide 5 by 2, is the remainder 0? No, the remainder is not 0. That means it is false. Therefore, what is there? Is there anything within the loop except this if statement? No, there is nothing except the if statement. So what will happen? It will continue with the next iteration of the loop. That means it will check. Now I will take the value as 3. So again the checking will happen. 3, the number is 5. 5 modulo divide n modulo divide I. 5 modulo divide 3 equals to 0. Now also the condition is false, because now also we cannot divide 5 by 3 exactly. Then again, now I will take the value as 4. So if n modulo divide I, that means 5 modulo divide 4 equals to 0. Now also the condition has become false. So now also it cannot go inside the if statement. Now all the values within the range are completed. Therefore the loop has been terminated normally. Now since the loop has been terminated normally, the control will come to this else statement. What is this? This is the loop else statement. So what is written there? N is a prime number. Now what is n? N I have given as 5. So what will be displayed? 5 is a prime number. Okay. Now let me take a different input. Now let's say the input is your 9. So let's take the value of n as 9. Let me just erase this particular board a little bit. Okay, so now we have taken n as 9, that means number we have entered as 9. So after that what will happen here? Here we have a condition which says if n greater than 1. What is the value of n we have taken? The value of n we have taken as 9. So if n greater than 1. 9 is greater than 1. Is it true or false? Yes, it is true. So it will come inside the if block. Within the if block, what we have here? Here we have a for loop for I in range 2 comma n. So what we have here, for I in range 2 comma n. So 2 comma, what is n? N is 9. So what will be the possible values? 2, 3, 4, 5 up to 9. Now at first I will take the value as 2 and it will come inside the loop. Within the loop, what we have, if n modulo divide I equals to 0. What is n? N is your 9. Modulo divide I, what is I? I is 2 equals to 0. So if I divide 9 by 2, is the remainder 0? No, the remainder is not 0, therefore it is false. Okay, as you can see, we have only the if block within the for loop. So now since the condition is false, now the next iteration of loop will be executed. Now I will take the value as 3. So here again this condition will be checked. That means 9 modulo divide 3 equals to 0. Now is the condition true or false? Now the condition is true, because if I divide 9 by 3, what will be the remainder? Remainder will be your 0. Now since the remainder is 0 here, therefore what will be displayed here? N is not a prime number. What is n? N is 9. 9 is not a prime number. Now since we have already checked till 3 and we have got one more factor, okay, which is 3 in this case, so it is unnecessary to check for the other values. That means it is unnecessary to run this particular loop again. So how can we terminate the loop? We have terminated it with the help of break statement. Now the break statement will be executed. Why the break statement will be executed? Because upon dividing 9 by 3 in the second iteration of the loop, this condition has become true. So it will be displayed that 9 is not a prime number. After that we have the break statement. Now since this particular loop has terminated because of the break statement, this particular loop else statement will not be executed. Okay, so if I type 9 here, I'll get 9 is not a prime number. Why this loop else statement has not been executed? Because at this time, for this input, the loop has terminated because of the break statement. And as we already know, if the loop terminates because of the break statements, then what will happen? Then the loop else statement will not be executed. Similarly, if I now take the run this program again and take the input as 1, I am getting here 1 is not a prime number. It is happening because if n greater than 1, if the input is 1, this condition becomes false, so it will directly be displayed as n, that is 1 is not a prime number. Okay, so this is how loop else statement works, and this was one of the applications of loop else statement. Checking for a prime number is a very important program from the examination point of view and also for trying to understand the loop else statement. So that's all for the day. I hope that this session was useful. Thank you very much.